know, please don't answer. So, what do you think? What do you think that's a picture of? I will tell. One hint. It is an actual picture, not artist drawing. Okay, so that much is clear. So, uh, but and if you think you know what it is, uh, please say it was. I'll give you another hint. It was taken not from the Earth, if that's of any help. Does that help? No. Okay. Uh, my gosh, let's see what it looks like. I want to see what. If I go to that link, what does it look like? Oh, that's my website, and there's a picture, and it says it. If you touch that link, it will give you the answer. If you touch that link, it will tell you what it will give you the answer to that question, right? Uh, well, we lost some volunteers. Uh, all right. Uh, let me see. Let me see the profiles of the people I'm here. See what I can do. We have Omalad Odetera uh, is, in fact, it's into space exploration. Surely you have something for me. I mean, you are right on topic pretty much. Except, of course, my topic is not space exploration so much as what is it out there that we already know about space that we don't need to go there to find out. What is it that's out there? What is the universe like? Is is in fact my topic, rather than Omalad. Uh, your topic is how to get there, more or less, which is different. Uh, I am interested in both, however, but if you will, expert in only one. Or trained, if you will, in only one. Expert in none, if you will. Uh, since I am way past the age of knowing, being able to hold myself out as an expert, except maybe in a room like this. So, come on. I've talked a lot. Let's see what we got here. Parth. Oh, okay, Parth. Parth is come up with an answer, but, uh, you know, right, that Parth is right in the backroom chat. Dash is here. Welcome, Dash. Uh, and so, but we're going on for a record tonight. Tonight is the longest I've spoken to myself before somebody volunteered to share this. There you go, Dash. Thank you very much. Thank you. That's very nice of you to show up and help me out here. Do we have a question, or we want to talk? What do you want to talk about? Uh-huh.
I kind of want to. I want to explore more about dark matter, if that's okay with you.
Sure it is. Sure is.
So,
Right, but you have to ask the question before I
yeah,
can tell you, give you an
I
answer.
got you. I was just thinking. So, first, if you don't mind, in a, would you explain the difference between dark matter and dark energy again? I know you did it in the last room, but I came. I think I came in a little late, and I was kind of in and out. But if you could just draw the distinction for me again between dark matter and dark energy.
Well, the word dark means I don't know anything about it. Okay, that's uh, and then and then you have two choices. The universe gives you two choices: matter or energy. If it's not one, it's the other, and that's the end of it. So basically, we're saying is we don't know about 95% of everything that the universe is composed of which most of it is the thing we don't know about called dark energy. The other thing we don't know about, which is called dark matter, which is like around 25%. So altogether, and then you have matter itself, which is one of those two, and that we know about because you and I are made out of it. So basically, it's saying we don't know is really all it's saying. And dark matter has the added qualifications that it might be matter and it might not be. Whereas dark energy seems to be agreed upon to be energy and not matter, because it doesn't make sense that it be matter, so it has to be energy. Uh, so that's the distinction between them, okay? Uh, and but there's more to be said, obviously.
Yes, sir. I just saw Haris come in, so I'm gonna actually give him a chance to if he wanna say anything.
Haris, yes. Haris, would you like to say something?
Hi, good evening, everybody. I literally just got in, so I'm not entirely sure what you were talking about.
Oh, he Dash was asking distinction between dark matter and dark energy, which uh, I appreciate, by the way, Dash, because uh, every time somebody asks me the same question, which is one of those things, I have come up with a different answer, and I like this one better than most of my previous answers, uh, because you asked the question in a different way. You didn't say what is dark energy, what is dark matter. You said what's the difference. So that was a different answer to a similar question. So I thank you for that. Uh, but uh, uh, but Haris, you need
I
to.
appreciate you inviting me in, Dash, but I really have no idea. A lot of things I could talk about. The dark energy matter. I really haven't. I'm still kind of understanding what the difference is because I think like you think you probably put it a few weeks ago, Laird, about like dark matter is kind of the material that kind of keeps as galaxies spin. It's what helps keeps the outer solar systems from like spinning off due to
Right,
the
right,
force of the spin.
right, right. But at the same time has almost no effect that we can measure in our own solar system because dark matter doesn't clump in the same way that matter clumps. So dark matter is equally happy between the stars as it is near our star. So it's really diffuse, and being the galaxy is over 100,000 light years in diameter, and our silly little solar system is like less than a light month in diameter. Uh, so basically, if you're looking for dark matter, you better look outside of our solar system because that's where most of it is. There's enough of it, given that the galaxy is so really big, that in fact a little dark matter, every little bit of a place, everywhere, is enough to hold whole solar systems from flying off into intergalactic space. So yeah, uh, it's. But we still don't know what it is, right? We still don't know what it is, but uh, there's uh, there's there's no proof that it in fact is matter, but there is some proof that it's not modified Newtonian gravitation. The way you modify Newtonian gravitation is you screw around with the exponent in Newton's 1/r². You screw around with that a little bit, and you come up with dark matter. But you have to then come up with a reason why you were able to screw around with the exponent of that term, because it still doesn't make any sense. See, it's either matter that doesn't make sense, or, or gravity that doesn't make sense. But in either case, you don't know what it is.
Yeah, that was I was I remember you really went down that path of describing the modified new the parallels between the modified Newtonian physics and dark matter. Um, and that blew my mind. That really blew my mind. So I'm glad you brought that back up. Uh,
Yeah,
I have questions regarding. So this is actually a couple. I'm trying to like uh, streamline. So first, I want to say, okay, if dark matter is matter that we don't know we don't really know what it is. Dark is you said we don't know. Does that mean that this if we do start to find out, hypothetically speaking, that this dark matter is in fact matter, will would that mean that we will be adding new elements to our periodic table?
ha,
Or
ha, ha.
Wow, that is a really interesting
But
question.
actually, the answer to that is no. But the answer to the other question, which is exactly what you mean by what you said, see, the periodic table is all about matter, okay? But but the Hold on, give my brain a second to come to order. Uh, the oh God, the 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 this is my problem with age. This is a word I've said hundreds of thousands of times and can't say it once now. There's a picture of all the different things that make up uh, matter, make up the it's the
Periodic
um,
table.
no, it's things like quarks and mesons and
Oh, the
pions
standard the
and
standard model.
neutrinos. What?
Are you talking about the standard model,
Thank
or
you, thank
okay?
you, thank you. Okay,
Got you.
it's getting worse every year. I'm going to be 79 soon, and so yes, the I lost it again. What's it?
This the
The word,
standard
please.
model.
Thank you. You see, I thank you.
Thank you.
Okay, standard model. Okay, the standard model has this stuff in it. Okay, and it uh, has a number of things that are made up of matter, and it has a number of things that are made up of energy. Uh, so, for example, there's a thing called a gluon. It's not. It's energy. It's not mass. It's it's in fact. It travels at the speed of light because it's not matter, and it exists only within the nucleus of an atom. It's a gluon, and it is said uh, recently by something I read, so there, that the most of the mass of a nucleus is made up of gluons, which is pure energy, and quarks, if you will, really are much less in terms of the contribution because mass and energy is the same thing, you know. So gluons make up most of the nucleus in terms of mass, although it's massless, uh, and and there's an X number of these particles, and I believe X is a number which I constantly forget, but is something like 30. Okay, so there's 30 particles, of which some of them you can put together to make atoms, which you use to make the periodic table. Okay, but there's lots of stuff like neutrinos, which will never ever be found inside of an atom except momentarily while it passes through it. Uh, so, uh, so, so is now the question is dark matter uh, something that would add to the standard model? And the problem is that the standard model is in no way able to predict this thing. So you can if we can figure out what it is, then we would have to, if you will, turn the standard model into something that explains it, or more likely, we would have to retire the standard model in favor of the new standard model, whatever that is, to explain it and dark matter and those other particles. So no, it's not a change to the periodic table. It's a change to the standard model. And I can't speak more than that about it because, in fact, I have the same question. If I was meeting with a particle physicist, one of the questions I would ask them would be, if we discover what dark matter is, would we have to change the standard model? I would ask them that question rather than giving you an answer. I don't know the answer.
Gotcha. Um, okay. Are you uh are you familiar with supersymmetry? Right.
Enough to know that I can't understand it enough to explain it. I
That
have
you can't
no,
understand.
really. It's the entire standard model is, in fact, I've ruled it out as any attempt for me to ever say anything about it, except occasionally name some of the particles, occasionally. But no, supersymmetry, no. I really don't know what it is. It's not that I haven't read it; it just hasn't stuck. Okay, so I don't. You can look it up and read it to me.
Okay, give me 1 second.
Yes.
Well, I was actually going to start querying you. I was going to start hitting you with queries, but
You know, no, really, no, no, no. CPT, CPT symmetry. Okay, I don't know what it is. I know it means charge. No, no, it means charge, parity, and time. Okay, I know what that means, and I barely know what that means, and I would have nothing to say about supersymmetry at all. But it's down that line that you're talking. We have a person who has a question. I hope they have answers, uh, uh, and perhaps yes, perhaps no. But anyway, our new friend Angry F is here, in case he or she wants to speak.
Thank you. Might I, or is it? Should I wait for my turn?
No, you go.
Awesome.
Uh,
Okay. If we are living in a four-dimensional cube,
uh,
as be it the three-dimensional existence we're experiencing.
except for the cube part, I'm happy with the four-dimensional space, but it doesn't have to necessarily be
Yeah,
cubic.
not necessarily. It
Okay,
could be
but
a
yes,
diamond,
of
could
course.
be a whatever.
Okay, fine.
It could be a thing within the thing within the thing.
If you say
Not
that's
the point.
yes, not the point.
But the end extension should be the fitting of a hand. Wouldn't you agree?
The fitting of a hand. I don't know if I even understand, much less agree. What do you mean?
Like the eternity dimension and beyond eternity dimension and beyond eternity dimension until you reach a number that could be called Raralion, be
Actually,
it
I don't know those words. Let me see. In your profile, you do mention some words that are I can see now are words that I'm not familiar with. Uh,
okay.
so I am not familiar with gamma level business, gamma level creature. I'm not familiar with uh, uh, so no, I don't understand those words. Level
Okay.
against, yeah, I don't
Okay.
understand those words.
If I assume that the capitalism era we're living is mail order alpha beta gamma.
Okay. Again, I didn't understand that, but continue. I'm just going to go down the line, not understanding everything you say, apparently. But go on.
Is it Jewish funny or Egyptian funny?
Uh, I think it's the same sense of humor, personally. Uh,
Thank you.
yes, right. No, I've been in Egypt 3 times, and I think they get my humor. So at least my tour guides have. Uh, so anyway, continue. Is this going to mount up to a question ultimately, or are you just going to tell me some more words I don't
so,
understand?
so I have a
No,
question if we're
I'm
really
I'm
like
happy to
building up one.
explain, and I'm really interested if you could explore
Well, let me
the
ask you this.
concept.
Let me ask you this. These words that you're saying, they are alien to my world because apparently you have a different subculture than I do.
Data scientists might find it relevant, or only data scientists could
Data
find it relevant.
scientist. Data
Only
scientist.
if they're studying the same field that I'm studying,
What is your field you're studying?
era science.
ERA science. What does that mean?
The science of this period of existence, be it quantum and the level of beyond quantum.
Uh, Let me ask you this: you're studying this in? Are you currently studying it?
Uh huh.
In
But
what?
not institutionally.
Oh, I know, that's what I was going to ask next. In what?
I applied. I just recently, 2 days ago, I applied to Harvard to actually establish the science there, but I'm still pending.
Well, what is your undergraduate education in?
Computer science. I have a bachelor's degree in computer science.
Okay. No, this is interesting. See, the thing is, I'm trying very desperately not to make fun of something I don't know anything about. You know what I mean? Uh,
Uh huh. No, but feel free. I accept humor with
right.
a
No,
very
no.
open heart.
The thing is that that it's hard for me to identify things that I don't understand that in fact are real sciences. You know what I mean?
Even if
And
it's a mystical science, it could be an addendum to the M theory. Could be even.
right.
But
So
if you inspect the Raralian number, be it Ra, be it
what is the Rowleyan
88,
number?
88 from the perspective of chemical element, atomic number, radium, Ra,
Okay,
Ra,
okay.
88, 88, four eternities into a gazillion
But
addition of
I
zeros.
don't understand the word eternity in the
Uh-huh.
sense that you're
Uh-huh.
using it. Eternity to me, well, I
When
would say,
eternity is creator going to count, and the moment he gets bored of counting, that's eternity.
okay, in the word eternity, by the way, if anybody's bored with what we're talking about, I'm just amusing myself and learning stuff here. But if you feel to, you need to add to this conversation, please feel free to put yourself on the stage and invite yourself, and I'd be happy to talk to you. So anyway, the thing is that in your system, is there a beginning but no end? Is that the idea? So time began but goes on for infinity. That's how I would say it, and then I would call that eternity. But I also might go so far as to say that time didn't begin, so it was always and will continue for always, and that's eternity. Is that your definition of it?
Um, if you consider the end is a bonus.
Well, I see. I don't consider bonuses as being anything to do with science, because bonuses are human, and science is sort of the things that you would observe about the universe itself, in the absence of us. So bonuses don't exist in my world. So I don't understand.
Is the sun moving in this realm?
This, in the world that I come from, the movement is always relative to an object
To
which is
time and space.
arbitrarily defined at rest, and everything else in the universe is at movement with respect to something at rest. You can never say in my world, you can never say the words something moves. You can never say that. It's an anathema to me. You have to say it moves with respect to. If you don't put the words with respect to, my ears shutter up, and I stop listening. So
Yeah,
so
that's something new I learned. I'm not. I remember failing in physics at least once,
uh-huh,
and when I succeeded, I didn't really succeed with a good grade. It was a D minus, I feel.
a D minus. It's hard to get a D minus. No, really, no, really. I mean, that's how do you pull it off without failing? I mean, unless you were intending that, which of course then would be an achievement. But no, uh, my hold on. I got a text. Uh, Let me just say yes on Clubhouse, and that's the answer to the text I just got. Sorry. Uh, so I lost my train of thought. Uh,
D minus.
D minus, yes.
Good one, Maurice.
Right. Well, now let me ask you a question. Okay. So you're applying to Harvard, okay, with a D minus in physics, okay, which is not your best credential, right? So what is the credential that you hope that they will glom into to in fact say, hey, we need one of him in addition to the all the people who also applied but did not get a D minus in physics. So what is your field, if you will, as far as they're concerned? What is it that you contribute to their world?
The question that I will ask when you break down Harvard is the V perspective to the fights we're having and will have and we had. Is
Fights?
that the kind
Did you
of
say
V in the middle of the Harvard?
uh, uh, fights? Did you say fights?
That's what I
Vicious
heard.
fights.
That's what I heard.
Vicious
Well,
fights,
the
exactly.
universe,
Like the
the human
VS
beings are.
as a short for VS versus.
Uh huh.
So
Harvard.
AR, VAR,
Mm.
assault rifle, and the H and the D. Is it
I,
HD fights
I,
or
I'm
less
not.
than HD
I'm not
fights?
into the as many people are into the meaning of letters and words in text and otherwise. I don't consider that to be so much a science as a discipline, uh, and uh, and as such, I'm not familiar with it nor interested.
It's more that type of language is more subjective
Right. Right.
versus yeah. But I kind of see. I think I kind of see the two ends that you, Dr. Laird, and Angry F are on. It seems you're like strictly in the physics realm, and I think
That is right.
uh,
That is right.
Angry
I
F
mean,
is kind of in between.
Not entirely in the physics realm.
no,
I'm
no.
not dipping
One
my
of
toe
the
in physics at all.
no,
I'm
but
dipping my
what
toe specifically in geo coordinates. That's it. Of
uh,
the physics.
see
And
what I like to
no more, no less.
what I try to do here, really, and this is really true. Uh, I mean, as a human being, I behave like everybody else, with basically spouting my opinions and going off the rails about this, that, and the other thing. But in this room, I try to hold myself out as a person who holds people's toes to the fire with respect to speaking only things that science is in fact agreed upon, and not my opinion, not your opinion, and I try, if as much as possible, to label things that come out of my mouth as being opinions, uh, and and two, in fact, label the things that come out of other people's mouths as opinions, and as such, it does not. Uh, I do not like to, in this room, entertain opinions about things. Although, when the room ends up going that way, and it's a free for all, what I do is I change the title of the room, because I can do that now, and I can say, go at it, you know what I mean? And then it's not no longer ask Dr. Laird your stupid astronomy questions. But right now it is. So I would like to encourage you to ask me your stupid astronomy, which means, by the way, that not that it's stupid, but that you might consider it to be really not a good question. Whereas I
Awesome. I'll
always,
circle back to my original question then.
yes, it's a question. A question.
Just
Go
one,
for it.
can I make just one comment about changing
Yes.
the name of the room?
Yes.
Uh, yeah, I understand you change the name of the room because you leave the room and then the subject changes, but it
Yes.
kind of, for historical purposes, it kind of screws up the room because if I'm searching for an old astronomy room to
Oh,
listen to for a replay, it won't come up.
oh, okay. So I won't do that, or I'll leave. How about if I
Yeah,
leave the title in there, uh, and use the word astronomy, change it slightly so Laird astronomy and questions, it was retained. The word stupid is just because there's a limited number of characters. The word stupid is removed, and it could be Laird and astronomy questions or whatever, and
okay,
and and then and then it would be searchable
there you
by
go.
most of the keywords. Thank you, Jake. That's very helpful. I was wondering about that. I was wondering about that. So
Okay,
thank
over
you.
and
Okay. Angry F, ask a question.
The reality we're living now, the 3D reality we're living in, if you present it on a piece of paper and you go diagonally and x axis also, but put uh, on the horizontal, is it the one that's like
Yeah,
cutting
the
the
x
piece of cake?
the
Yeah,
x-axis. Yes.
I told you I'm a D minus in physics, so that's like off the top of my head, non necessary or non existent. It's
Uh-huh.
deep down in the
So
consciousness, quantum.
you're not good in math apparently either. So
I'm good on math when I have the pen and paper. If I don't have the pen and paper, I can't do it. Yeah.
okay. Right. Go on. What's the question? Continue.
So if you put letters and numbers, if you go all the way up, infinity wise, up top, do we have infinity approximate? Is it still big data, or is it bigger than big data, or what kind of data would be called then?
Infinity rules an entirely other realm. You can go
I'm
all the
presenting
way.
Roralian. I'm only presenting it. I'm not
No,
saying
no, but I
that
don't know what Aurelian means.
Raralian,
Oh, I don't know what
Raralian.
that. I do not know what
Yeah,
that word means. Still do. Still don't. Still
Yeah,
don't.
yeah, right.
it's a proposal, dear doctor. It's
Okay.
just a proposal,
I'll
dear
just
doctor.
I'll take it as a word. So what's the question?
The question is, would reality then make more sense or less sense?
Well, uh, here's my opinion. Uh, Reality is not well defined. Okay, and again, my opinion. Uh, and anyone who chooses to define reality uh, defines it in the absence of science. That's my opinion. Okay, so I wouldn't begin to talk about reality.
That's fine.
I would love to agree and subscribe to that opinion, sir.
Right. I
That's
have
a
my
good.
own opinion about. You want to hear what my opinion about reality is?
Yeah, please.
Please.
Okay. My opinion is that reality only exists in language, and in the absence of language, reality doesn't exist.
Uh,
What is
what
language?
about letters?
In other words, cats don't
What about
don't
numbers?
ex,
Sorry.
no, cats don't experience reality because they don't have language. Only human beings experience reality, or only those beings which can express things in abstract terms.
So are
Only
you
those
speaking?
beings. That's my opinion, boys and girls. It is
I
not
don't argue
it
with
is
you.
not
Yeah,
verifiably
that's
true.
that's interesting though. Like, are you? But when you say language, I just want to know what your definition is. Are you talking spoken, written language, or are you including body language, nonverbal, like all that,
Yeah.
all those
Telepathy.
No,
extra
no,
like?
I am in fact only talking about symbolic language,
Symbolic
not body
language.
language
Okay.
in this case.
Okay.
Although I agree that most animals, if not every animal, communicates with some sort of language.
Yeah.
But I'm only talking about the kind of language that abstract ideas can be expressed, like the word chair. If you can find another animal that can express the word chair, and I believe whales might do that, except they don't have any need for them. But and I'm sure whales do have a language, right? And I'm sure whales do fall under the category of the type of being that, in fact, experiences reality through language. Okay, but that's my opinion, that it only exists in language, which, if you want, you can say, does that mean that if you stop talking, the universe disappears? And my answer to that is, uh, uh, I'm not going to answer that question. Okay, so yes,
So
Well,
I got
I have a
One
question.
aspect freezes. One aspect, which is time. Yeah.
which is what?
oh,
What?
say that again.
One
I'm sorry,
aspect freezes, which is time
I didn't understand that again.
One aspect of what?
of reality.
Yeah.
One aspect of reality is time.
No, one aspect of reality stops when you stop talking.
No, actually, reality only
Oh, one
exists in.
aspect freezes. Oh, I got you.
I
Got
see,
you.
I see,
I
I
got,
see. No, yeah, I wouldn't go there.
Thank you, Dash.
so I have a question. Kind of.
Yeah.
All right. So like so, Dr. Laird. So
Yes.
if actually for everybody in a room who wants to respond, who has any, yeah. When theoretical physicists, right, when they start to uh, develop like equations or do calculations or what have you, and come up with these
Mm-hmm.
equations that
Mm-hmm.
we haven't tested, in the laboratory, we haven't did any like experiments on yet. But then, the equations they just work so well. They describe what we're observing so well that we just kind of stay with them, and then until we test them, and then when we test them, let's just say that these equations get verified, or
Mm-hmm.
we test them and they work and they
Right.
align well.
One example of that would be quantum mechanics.
So I'm okay. I kind of want to dig into that. Why you said that? Why did you say quantum
Well,
mechanics
quantum
is one of them?
mechanics is a set of equations which pr- predicts, has never been falsified, and has been proven to be true by never having been falsified. Uh, and uh, and it was created to try to explain the phenomenon that otherwise couldn't be explained.
So because it's never been falsified, but has it been proven true?
You can't prove something true. You can
You
only
can
prove
only
something
prove it to be
false.
false. Yeah. Okay, I got you. Okay. So with that being said, kind of with that being said, when we do experiments and these experiments aligned really well with our equations,
right?
is that, would you say that that's a prediction or a coincidence?
Certainly not a coincidence. It depends. If you predicted it from the equation and then it was found, then it's a prediction. If if you if the equations explained it after the fact, then it's an explanation. It's and we take the mathematics as being the expression of of the situation of the science. The science exists in for many situations, certainly physics, uh, in the equations, and not in the explanation of the equations either, just the equations.
So this is going to sound extreme. I would imagine that this is going to sound extremely stupid to you,
Ah,
but it's
good.
like it's very illuminating for me. So
Okay.
for a long time, I've always viewed mathematics as a way of describing our reality.
Hmm.
Um, but I've never seen it. I've never really looked at it or appreciated it from the end of predicting our reality. You
Uh-huh.
know, so I've always looked at it. I've always looked at it as a tool that we use when we see something happen or we do an experiment and something happens. We write mathematics that describes that.
Right.
But I've never really like sat
Well,
and
what about
absorbed in it.
we know where Jupiter is going to be tomorrow. How do we know that? It's because we use the mathematics to predict what's going to happen in the future. We are we are predicting the reality that occurs in the future. Since 1600 approximately, when Newton came up with this stuff about gravity, scientists have held out the idea that science can predict reality, which has gotten them into a lot of trouble in the 20th century when it was discovered that there's a lot of horseshit going on about science that isn't true, and certainly we can't predict very much when it comes to some of the softer sciences, which are still called sciences, you know. But in the realm of physics, uh, specifically, and astronomy and, for that matter, chemistry, uh, uh, we can predict through our equations what the reality will be. Uh, and other sciences, much less so. We can, for example, when it comes to quantum mechanics, we are reduced to blithering idiots if we think we can predict the reality. We can only predict the statistical likelihood of the reality. And we are told by the statisticians who breathe and teach quantum mechanics that you can never predict the reality of something using quantum mechanics, just the chances that that will happen. That can be predicted with 100% faithfulness, but not the actual event. So if you do something, so you can say that you can flip a coin 100 times and come up with not 50 heads and 50 tails, but approximately 50% will be that way. And the more you flip the coin, the more likely that it will approach 50%. So that after 10 million flips, the chances are it's been 50.0001 versus 49.09999. So the better statistics you get, the more close you get to being able to predict it with uh, complete accuracy. Otherwise, there is, if you will, an error associated with the prediction. And that's quantum mechanics built in from day one.
And Siri now is quantum computing, be it heads or tails, and she flips and sometimes rolls the decks. So she's quantum already.
Who is quantum?
Siri,
Who's Siri?
The
Apple's,
iPhone
yeah,
AI, yeah.
Oh, well, Siri's just, yeah, okay.
And
categorically
In that case,
quantum.
okay. No, right. So and here's the other thing, is that then a little known factor in the world of physics has interjected its little head, and it says, guess what, you guys? It turns out that if you think that you could even predict where Jupiter is going to be tomorrow. And remember, I used that as an example, right? I said, well, you can predict where Jupiter is going to be tomorrow because you use the equations. Well, it turns out that yes, you can predict where Jupiter is going to be tomorrow, but there's a but. You have to know where Jupiter is today. And you don't know where Jupiter is today exactly. There is a certain amount of error in your measurement. Maybe it's a quarter of an inch, maybe it's a millimeter, depending on your system of counting things. But that millimeter will make a difference a million years from now when you won't know where Jupiter is going to be at all. So, in fact, where the planets are going to be millions of years from now is unknown to those people who know the equations to the nth degree. The problem is they don't know the initial conditions. And that, my friends, is called chaos theory. The fact that we don't know everything about what's going to happen in the future, no matter what, because we cannot measure things to the nth degree. There's a limit to how much we can measure, and things can be, in fact, ornerier than that, and just given enough time, they will go its own way. So we say that butterfly flapping its wings in Japan can affect the weather 2 weeks later in the United States, and that's true.
That's great.
Yeah.
That-
Yeah.
That's really interesting.
Um. Yeah. Definitely. Do you go ahead?
Yeah, no, I'm just taking a breath here.
I do have a question. Like I read an article a few weeks ago about how like they're now, well, some scientists are thinking that a large part of the water on Earth came from asteroids in the early
Right.
planet. And I think of like asteroids that land today, like most seem to be the size of a potato or a little bit more bigger, maybe have like some molecules or a few drops of water or something. And I think of like how much water is on this planet
Hmm.
to how many asteroids would have had to have come here, like help make that make sense for me, because like
Okay.
I would think like a huge mass of the planet would have had to have come from asteroids to begin with
Right.
for there to be so much water to come from
Right.
those asteroids.
Right. So that's an interesting controversy, and I wish I know the answers to the questions I'm about to raise, but I do know the questions, and the questions are: where did we get the water? Okay, where did the water on our planet come from? And I'll tell you what the problem is. Uh, uh, let's say you're making a planet, uh, something like Earth, in something like one astronomical unit from the Sun, 93 million miles, uh, and so you're building a planet, and you're building a planet, hopefully that's from stuff that's nearby, because otherwise, how's it
Right.
going to get here? So if you look at the temperature in the early environment in which the Earth was created, it's too hot for water to condense into a liquid. It's only a gas. And as a gas, it goes flitting around the solar system willy-nilly because it's basically not affected by the gravity of our own planet. Our planet isn't big enough to suck up the gas. Guess which planet is big enough to suck up the gas? It's called Jupiter. And guess how it got so big? First of all, it sucked up a lot of Earth-sized things, okay, until it got to be about, say, 10 Earth sizes. And then that was enough to suck up the rest of the hydrogen and helium that was lingering in its vicinity. So that's how it got big, by
Oh, that's really
sucking up by
interesting.
sucking up gravitationally the gases. But hydrogen and helium are no different than water vapor when it comes to that. It's just that back there was in fact, it's called a frost line. So guess what was solid at that distance? Water was solid at that distance. So water was also being, if you will, impacting the planet, being drawn in because it was no longer a gas. You see, it was
Hmm.
a solid. Around where Earth was formed, there was only this gaseous water, And so, according to popular hand waving, it was unable to be accumulated in the original Earth that was formed. So there was no water on primordial Earth. Okay, so if you buy what I've said so far, then you say the next question is where did it come from, and then the answer has to be, well, the asteroids and the comets. That answers the question if you believe the Earth didn't have water to begin with. So, first of all, recently there is some conversation that says, wait a second, I don't buy the first part of your argument. I think the Earth did have water to begin with, so we don't need the comets to bring the water here. Okay? Uh, uh, but uh, uh, that's just a new theory, so we don't know the answer to that one. And it's hard to be able to figure it out because guess what? You can't go looking inside the Earth to find it, and it's hard to to come up. It's theory, and theory, it requires mathematics, and mathematics can be screwed around with if you don't know what the initial conditions were, which we
Mm,
don't, right? Uh,
yeah.
if we do know the initial conditions, then we could work it out. And that's one of the reasons that the James Webb is going to be very happy because it tells us what the initial conditions were in early solar systems, which will help us understand how our own planet got formed. But anyway, coming back to uh, uh, the so now this is I love this story. This story is so good. I love it. I've seen movies of this. It's not great movies. It's not like something that Spielberg did, but it's something that a cartoonist did. And what they show is the orbits of the four outer planets: Jupiter, Saturn, Uranus, and Neptune. Okay, and uh, and uh, and at some point in the early, hold on, I'm getting a message from who knows what person, and I always get, went wrong. Please try again. Oh, it's actually it was my phone telling me that something went wrong. Thank you.
Oh, your
Anyway,
phone was calling
uh,
you.
nobody was calling me. It's just
That's-
my
that's-
phone my phone just aborted, which is not never
no,
happened
no,
to me
no.
before.
I said your phone was calling you.
Right.
Everybody was
So
going
what happened was in the early solar system, there was so much stuff in the early solar system, so many objects, so much debris that uh, the planets, uh, some of the outer planets, exchanged places with each other. Uranus and Neptune, for example, exchanged places with one another. And in the process of doing that, disrupted all the happy debris that was making minding its own business in the outer solar system, sending it crashing down into the inner solar system, carrying with it the water that we today so covet. Okay? And one of the pieces of evidence of this, because this is not all theory, one of the
oh,
pieces of evidence of this is if you go to the moon and you bring back rocks from the Apollo missions, they all tell you that the moon was hit 3.8 billion years ago by a the late bombardment, I think it's called late early bombardment, that the moon was essentially resurfaced 3.8 billion years ago uh, by a heavy bombardment of stuff that also impacted the earth and brought the water. So, so where the water came from is a question uh, on the earth, and I also spent a year of my life answering another question, which is how did Venus lose its water? Which is also equally interesting question because you would think that Venus would have it if the Earth had it. So how come Venus doesn't have it, and how come we do have it is another question entirely. So it's all very interesting, and I would hope to learn more about that. Where the water on the Earth came from, in the coming years. It's a burning question for me, and
okay.
exciting.
I think there are some theories that it was deposited here by comets and
Yeah,
whatever.
that's the late early bombardment or the early late bombardment. Yes, that's it. That's how come.
How big is the comet relative to Earth?
Small, But if you get millions of them, it's big.
Fair
Really.
enough.
No, really, the the number of comets out there right now is small compared to the mass of the Earth. Yet there's trillions of them, uh, and they just haven't bothered to come our way. But they're out there.
But
Uh,
as far as water, just in general, forming in anywhere in the universe, it's just a chemical reaction with hydrogen and oxygen.
right. So
Uh,
so water is everywhere in the universe. It's. I always used to think it was pretty funny, and in fact, so did the scientists who said this. Uh, every time they discovered water on Mars, it became news until it became tiresome. Uh, but Mars has an awful lot of water, an awful lot of water. It's just below the surface.
and apparently the moon
The moon
has
doesn't have a lot of water, and apparently it's nowhere to be found except in some small, forever dark craters. And I'll be interested to see how that works out for them.
well, I thought
But
on the on the poles, they
yeah, on
didn't
the
they find
poles. So
ice.
they didn't find a. What they have is detected, and that's been very different. Finding would be go there, dig some up, carry it home, put it in a bucket, see if it floats. You know what I mean? They they didn't find it. They have detected it, and they are sure that there's stuff there. What they don't know is how much. They don't know how much. They have guesses and they have theories and stuff like that, but there's no uh, assurity to this,
Mm.
and they will eventually. And so, but enough assurity that we're racing China uh, to get there. You know, spending tens of billions, hundreds of billions of dollars to do so. So we definitely think there's something there.
A little bit
When
of
you
a.
when you oh,
Oh,
go
sorry.
ahead,
Go ahead.
Harris. Oh, I
I
was
was just about to ask a different question, but go ahead if you're on still on the topic.
nah. You go, bro. You go. Oh, actually, yeah, I'm still on this topic. One second. So Dr. Laird, so when you said they detected it, is how are they detecting like molecules, like the HCO molecules, or
Yeah.
is it the conditions? Okay, so they're
No,
actually
they
getting.
actually detect the molecules. One of the things they've done a number of things. I forget. The only one I remember right off the top of my head right now is they uh, they sent a probe uh, directly to crash into one of the craters. Okay, followed it by a probe that did nothing else but measure the spectrum of the emitted light before it crashed into the same said crater. Uh, and so that's one way of doing it. There's other ways of doing it, detecting. Uh, uh,
'Cause didn't they like detect like water molecules and like these like volcanic glass beads
uh,
um
yeah, I
from
think, but that's different. That comes from everywhere on the moon, and so they have detected a certain non-zero amount of hydrogen and oxygen in those beads, if you will, but not enough to be worth digging up the moon for the water necessarily. You know,
Well,
I don't
if
listen. Who knows
if
what's
it's
below the
it would just
surface?
boil, right?
What's that?
I mean, if it was exposed to the sun at all, it would just boil off and
Right.
evaporate.
No, but you can do stuff. I mean, look, uh, the future is going to be upon us. All you need to do is you create a furnace on the moon using the sun's rays, which are there for 2 weeks out of the year, and you concentrate the rays of the sun uh, on a little piece of rock, and you vaporize it, and then you can take the vapor and do with it what you will. If you ionize it, you can send it in any direction you want. So you could conceivably, easily uh, mine the moon for water if that made any economic sense. Uh, all right.
What would you say about the water that was found on Europa, or maybe detected on Europa?
What's Rupa?
Europa, Jupiter's icy
Oh,
moon.
Europa. Okay. Say that question again.
What would you say water was also detected, or it's is it definitive, or we still don't know?
Oh, no, 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 no. Anything beyond anything at Jupiter and beyond has got water. It's got tons of it. Everything. Nothing doesn't have water because that's where the frost line was. So the only question is, what is the water doing? How much of it is there? So Europa has an ocean of water. It's not a question. It's at this point it's dogma. Europa has water. Conversation ended. How deep is the ocean? Uh, is a question, but there's no doubt that there's an ocean on Europa
Why do you think it's not on the surface?
because water evaporates and water sublimes. So you can't have liquid water on a planet that doesn't have an atmosphere, or on a moon that doesn't have an atmosphere. But the surface of Europa is covered with ice. That white stuff is ice.
Okay, thanks.
It's just a question of what's under the ice. And if you think twice about it, it doesn't take very long to figure out that the deeper you go, the more liquid it becomes. Look at our planet. You go down, it gets hotter, right? People in deep mines in our planet get hotter and hotter the deeper you go. That's true everywhere in our solar system. Every single thing that is round gets hotter the deeper you go.
Oh, but I thought it's hotter because of the mantle. Does every planetary body have like an iron core or like a mantle, or could it not be frozen to the core of the planet?
No, but you see, the thing is, all the planets have a certain amount of radioactivity. Radioactivity. So there's two things. Uh, when the planet forms, gravitational energy is converted into heat energy as the planet forms. Jupiter is to this day still contracting from its original formation 4.5 billion years ago, uh, and 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 every one of the moons and planets have enough radioactivity in its core to create heat. But in the case of Europa, it's not uh, the heat of the core that's heating it up. Okay, it's the tidal forces of Jupiter itself that causes the the heating of uh, the internal heat. Literally, you can see the marks of the tidal forces of Jupiter and and the other moons on the surface of Europa. There are literally escarpments that can be, in fact, explained mathematically by the tidal forces of the other moons and of Jupiter and of Europa's orbit. It doesn't require radioactivity to heat up the Europa. It's interesting. If you see Europa's escarpments, you see these sort of eyebrow-shaped paths on the surface, and they are uh, predicted mathematically, which is, I think, very interesting.
So,
And
out of curiosity, is it just those two, tidal forces and radioactivity, that causes it?
on Europa, it's tidal forces. On Pluto, it's probably tidal forces. Uh, but Pluto has a moon, right? That moon causes uh, uh, tidal forces on Pluto, and Pluto causes tidal forces on Charon. So there's probably oceans below each of those. Titan, Neptune has oceans below it. It has ice volcanoes. Ice volcanoes. You want to see? Go to Titan. You can see ice volcanoes. They're
That would
probably
be
erupting
cool.
to this day. Water everywhere.
Why is it taking so long for Jupiter to condense down into a rocky planet?
Well, no, it's got a rocky core. It's just that I don't know the answer to that question. I'm just going to answer flippantly with it. Can't be bothered.
It can't be
I
bothered.
No, no,
disagree.
but in fact, that's not quite flippant. Think about it. What keeps what? Why don't you fall to the through the floor? Okay, the Earth is pulling you down. What's keeping you from going up? Well, there's something keeping you from going up, and uh, the uh, that is the electromagnetic forces of the molecules in the flooring below you. Okay. Well, what's keeping Jupiter from falling into itself? It's a good question. What is keeping Jupiter from falling into itself? Okay. Well, uh, so gas pressure. Okay. But the gas pressure down there is, in fact, it's there's a little equation called it's PVNRT. It's something like that, and it says that a certain temperature produces a certain pressure. And if you increase the temperature, say inside of a bottle, it gets the pressure increases, right? So how much pressure does Jupiter need before it does it says I got enough pressure, I can hold up my outer layers. I don't have to do it anymore. Thanks. I don't need any extra heat. So the heat that Jupiter is condensing is holding up the outer layers. It doesn't need any extra heat. So the outer, but when there's not enough heat, right, to hold up the outer layers say, okay, I'll fall in a little bit more. I'll convert some more gravitational energy into heat energy, and you can use that to keep up your outer layers. That's what I mean by can't be bothered.
So it's hot.
It's hot. And that's how the sun keeps itself up. And when what happens if the sun can't be bothered to produce heat from nuclear fusion, what happens then? Well, then it becomes a white dwarf. So you gotta every part of the sun is and every part of every star has a job to do to keep its outer layers up.
Yeah, I just read that Jupiter is 1,300 times the volume of Earth, but it's uh, only 317 times the mass of Earth.
Right. Right. Well,
Uh,
hydrogen is diffuse.
I think Carla has a.
So I have a
Oh, go ahead.
question. Yeah.
Yeah, Carla.
What's
Hi,
up,
So
Carl?
Carla.
hi. So wouldn't it? I mean, because the 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 El Nino and the La Nina, those are also tidal, and so wouldn't that be part of how
Actually,
you know what
I
I'm
don't know.
saying?
I don't know that the El Nino and El Nino and what's the other one? Yeah, I forget the name.
La
What you
Nina.
just said.
Yeah.
Uh, yeah, I don't know they're tidal. They are heat anomalies in the ocean, which cause climate change. But I am pretty damn certain they have nothing whatsoever to do with the word tide at all,
Well,
unless I'm
that's
wrong. But I
that's
think that.
confusing because it's the oscillations within the ocean, so that doesn't really make sense
Well,
to me.
no, no, I'm not saying the ocean isn't oscillating, and I'm not saying that. I'm just saying it has nothing to do with the moon.
But why would what would be so different about the change in oscillations in the ocean over tides? So how would that be
Well,
different?
tides are specifically the result of the moon. If you take away the moon, we don't have tides except from the
Ah,
sun.
so because you're not drawing the straight line between change in oscillations to the moon, you wouldn't say it's related.
Just give me a second. I've got to respond to a friend. I'm sorry, Carla. I just got a friend who just is confused. He's trying to get in. Uh, uh,
It's an interesting question, though, Carla. Like, does the tidal forces have an impact? Like, do they generate currents in the oceans, or is that just a product of the Earth spinning? Like, that's an interesting question.
Yeah, what's El Nino? You mentioned something about El Nino. I'm not sure I know what that is. Could you explain what it is?
So I don't know anything about El Nino. This is not, unfortunately, something that I have any real knowledge about. So I would accept testimony from anyone who knows what it is. but I don't know what it is. I just know that it is periodic in the sense of that it is almost predictable, uh, and that it has an enormous effect on the Earth's weather, and that it's a phenomenon uh, that occurs in the Pacific Ocean that causes the temperature of a certain region of the Pacific Ocean to become hotter than otherwise normally, and that affects weather profoundly for a year or two before and after, or something like that. That's all I know about it, really. But I know profoundly that it's not uh, a tidal effect. The tidal effects occur once a day. Uh, Once a day. The Earth spins once a day. If it's not a once a day phenomenon, it's not tidal. There's also another, there could be, if you will, the fact the moon goes around the Earth once a month. And so there could be a once a month thing because the moon is in an elliptical orbit around the sun, the Earth. So there could be, if you will, a tidal effect on a monthly basis, and that's also possible, but not over years. That's unlikely to everything I want uh, uh, to know. Uh, so,
Okay. So separate, like apart from that, um, could we say that since tidal forces have an impact on the heat of any particular planet, wouldn't they also have an impact here?
sure, the tidal forces have some effect on the temperature of our planet to some extent. I wouldn't discount it as being unimportant, but I think it's minuscule uh, because uh, uh, because the sun is basically the ruler of all, and the tides. I've never heard anyone describe the temperature changes due to the tidal forces. I'm sure it is because friction's involved, and friction
I'm reading
produces
that
heat.
it's
Well,
I'm reading
if
that it's
there's
caused by the trade winds, and when there's a weakening of the trade winds or a reversing of the trade winds, it prevents the cold water from coming to the surface of the ocean. And then
Yes,
El Nina is the opposite, where there's increase in winds and the water gets colder instead of hotter.
right. Okay, that is something I have read, and so I know that's true. Uh, but I don't know more about it than that. And the trades with and why that occurs is really unknown to me.
But does the moon have any effect on ocean currents? Like, does the fact that do the tides, the daily tides, have any influence on how the currents actually form?
I don't know. Uh, I it seems to me that it should. Uh, I mean, water rushes in and out of the Bay of Fundy like crazy. I've seen it happen. I've seen it happen. It's really ridiculous, and that rush of water in and out twice a day uh, is definitely has something to do with the ocean currents in some small way. But whether or not it has a major effect in the sense of that it that you would need to calculate that as part of your model. I imagine you do. I imagine when you are calculating ocean currents, you need to compute the influence of the moon. Sure. I just don't know how much it's important. Yeah. I have a friend who's trying to get to this room, and he has been making numerous attempts at getting in, but he's a complete clubhouse novice. And while he's a smart guy, he is just unable to get in. And I'm trying not to entertain his his he's constantly messaging me, and I'm constantly ignoring him. But just give me 1 second. Uh, yeah. Anyway, yeah.
I have a question about light, since there's kind of a little bit of a lull. Like, might be a silly question, a stupid question, a silly question. Like looking at the sun can damage your eyes, but looking at a campfire doesn't. Like, what is it about the difference in light from the sun versus light of a campfire that can create damage?
Well, the sun is at 5,000 degrees in this, in the, in your, the, and when you, when you focus a 5,000 degree heat on the retina of your eye, it will try to also become 5,000 degrees. Uh,
But with
and
also higher energy wavelengths, right?
because see, this is actually it's an interesting question because I'm about to uh, uh, hit a, a problem in my explanation. But the explanation I normally give is that uh, y- y- did you ever, as a photographer, uh, and some of you have been photographers, uh, realize that what you do in order to measure the brightness of a subject is you walk right up to it, you take a measurement of its brightness, then you walk back away from it, and having gotten that setting on your camera, which old cameras had these light meters built in, and before that the light meter was external. You get the brightness, you walk away, and you expose for that, and you get a perfect exposure. The brightness of the sun doesn't change as you get closer to it or further from it. But as as you when you concentrate it in the small little circle in the retina of your eye, on the fovea of your eye, you're essentially getting that temperature on your eyeball. So you are essentially about to burn your retina with that, okay? Because it's trying to achieve equilibrium with that temperature of the sun. Uh,
Mm.
uh,
Wow, that's so interesting. Okay.
So
but,
when
but,
if you
but let me just finish. But that same explanation doesn't explain why you don't burn your retina when you're looking at a fire. So I'm a little, so there's something wrong with my explanation, okay?
Is this
So
similar?
I take,
Is it similar with eclipse also? Like not having to look at eclipse.
no, well, the reason you don't look at an eclipse is because even a sliver of the sun can do the same damage.
Oh, so it's still kind of like the same thing.
Right. In other words, the brightness doesn't change, no matter how small the object is. Okay. Uh, uh, and for that matter, you would say, well, if you look up at the starry sky, you should burn your retina as well. But I think that you have some exception to the fact that these things are light years away. They're point sources, essentially. Uh, but the sun actually occupies a certain amount of angular diameter in your fovea of your eye, and so it will burn a scar into that part of the eye which is looking at that sliver of the sun. So you don't want everybody but Donald Trump needs to not look there. You know. Well, I've looked at the sun actually myself. You can look at the sun for a split second, because your eye will not reach equilibrium with the sun if you just stare at it for a split second and look away. You know, but if you look for more than that, you're going to blind yourself.
So it's more about the heat associated with the sun versus the campfire that creates the damage.
Right,
It's not there's
right.
not something about the light itself.
What happens is when you look at it, when you look at an eclipse, it doesn't blindly you, so you think you can look at it longer, but you can't. Same that you have to look at it at the sliver of the sun during an eclipse in the same way that you would look at the sun itself when at its full brightness. So if you look at a sun ever in full brightness, then you can look at an eclipse in the same exact way. But and I have uh, reluctantly never given that advice to anyone because basically, if you take my advice, you'll look for a longer period of time and you will hurt yourself. So I have never told
Right.
anybody to look at the sun, but myself, when I saw an eclipse, I did, in fact, stare at the sliver of the sun for a split second, uh, and it didn't kill me. But I only looked for a split second, the same way I would look at a full sun.
Sure.
well,
I
I
read
must
that
say that my
Newton also
eyes
did the same
are
thing.
hurting.
Right.
Um, Go ahead. I'm
Yeah.
Amalate. You were saying something?
Oh,
No, I was.
yeah,
Yeah.
I was saying like
Yeah.
I read that Isaac Newton temporarily blinded himself by looking at the sun too long for too long.
Did he?
But yeah, I think it was something I came across sometime.
Yeah. Us scientist type people do stuff like that. You want to see. Well, what happens if I do? You know. So I really don't know the answer. Like, how long can you look at the sun before you go permanently blind? Is a question I do not know the answer to, and don't want to find out personally. But I would be interested in what the internet has to say on that subject.
I just Googled it, and the first thing that came up is why did Isaac Newton stick a needle in his eye?
Oh, why? Actually, I think I've heard that. Well, why?
Uh,
Dr. Lloyd, have you tried that? To stick a needle in you.
No, no, I don't know why.
No,
That's
he's not dumb.
very painful.
Sorry.
I don't know, but the
Sorry,
first
Newt.
thought that came to mind was there was a, in the old days, they used to think that the eye emitted the light. The idea that
Right, right.
they didn't
Yeah.
know what light was, so they thought that the eye saw things by emitting something that would see it. In the
Speaking
Aristotelian era, yes, yes, Carl.
speaking of lights, there is a strange light in the sky over San Jose right now, and I don't know what's going on,
Uh-huh.
but it's unidentified and it's flying and it's an object.
Well, unidentified aerial phenomenon is the new word for it.
Ooh, Ariel, I like that.
That's the new word. So it covers UFOs and then some. It covers anything in the sky, including, see, you don't know it's an object, but you do know it's a phenomenon. And you
Sure,
haven't identified
yeah,
it,
right?
That's fair.
and you know it's in the
It's
sky.
That's
So
Does
fair.
that
and
does
you
that
don't know it's flying. So you don't know it's flying. You don't know it's an object. So
does,
unidentified aerial phenomena (UAP) is the new UFO.
okay,
does that come
flying
from
or
the
floating.
science?
There's a bright light in
Right,
the sky and
We're
there's two other
floating.
little lights behind it. I don't
right,
know what's going on.
right. So think about this. Can you imagine the people now who everybody's got cell phones, okay, and with a camera, all right? So everybody on this planet, half the people on this planet, are now qualified observers to take pictures of UAPs. And since uh, uh, the advent of the iPhone, nobody has come up with a decent picture of a UAP.
Ooh,
Don't you
that's an
think?
interesting
Isn't
point
that
there.
interesting?
That is really super interesting. You're right.
Right?
Yeah,
Right.
you think you'd
Because
have 5 billion photos of
that's
UAPs,
right. That's right.
right?
Or
If you
maybe.
pull
Oh,
to refresh, you can see mine.
okay.
That is
Hold on.
really interesting.
Let me see. Oh, uh, now there is a possible that I don't know what that is, but are you sure that's not a planet?
Yes, I'm absolutely sure it's not a planet. I just zoomed
How
in.
do you
Oh,
know?
oh, oh! It's no, it's right there. It's moving around.
It's moving around,
It seems to be
so it's
moving
not a
around.
planet. Okay. Well, even Venus moves around.
Well, it's kind of lower. It's way. It's like listen. It's kind of on the horizon as opposed to like up in the sky or anything. There's no way it should be that bright from this perspective. Like absolutely not.
So one of the things that people can't tell, uh, human beings are uniquely unqualified to measure distance, except for objects that they're familiar with. For example, they're very good at telling the distance a lion is from them. They have to know how important it is for them to run. But if it's unidentified and it is a dinosaur, right? Well, no, human beings have never seen a dinosaur, so you wouldn't know how far away they are. They could be if they were very far away, they would be small, you see. Uh, and if they're very close, they would be large. But you don't know ahead of time what the size of an object is from looking at something that is essentially a dot in the sky. So
Sure.
people always get that wrong.
Well, I did the zoom out, so now you can pull to refresh that. But I mean, it's literally hovering above the park that I'm about to ride my bicycle through
No, no, but
in
you
the
see,
night.
your eyes are not sufficiently wide apart to you to be able to tell distance.
But what if they are?
Well, they're not.
Wide
They're
apart. That's
not. You can only measure a certain. Given the distance between your eyes can only measure the distance of objects. And I'm going to make this number up because I don't know the answer to this. But your eye can only measure the distance to something that is an unknown size. And I'm going to say about 100 feet away. Beyond 100 feet, your eyes can't tell the difference between a battleship, or a toy battleship, whether it's
Well,
20, I think, and I don't know what the exact distance is, but I'm sure we could look it up and find out. It's called what is the angular resolution of the human binocular vision? Okay, that would be the question.
okay.
All right.
Well, I would just like to say,
Eh,
I grew up in the forest and there were no lights except for the stars. So as far as the
right.
stars, I'm a little familiar. I may not know where
No, no, I'm
all
not
of
saying
them
it's a.
go,
I'm not saying
but
it's a
I'm just
star.
saying.
I'm not saying it's a star. I'm not even saying it's a planet. I'm just saying is you don't know how far away it is.
I'm about
That's
to
all.
know because
So
I'm
he
going
doesn't
through the
know how
park.
far
I'm
it
gonna
is.
go through the park. I think it's roughly about there. They must be doing some kind of light show
Right.
or
For
something.
example, if there's trees in the park and it goes in and out of behind the trees, then you can tell that from other things. You can also tell one other way that you can tell how far something is away is because, unlike the moon, the things that are further away look fuzzier than things that are close up. So there is, in fact, a phenomenon called the fuzziness phenomenon, which I just made up the word because I don't know the right word for it because I forgot, is can be used to tell the distance that something is away from you. So that's also true. Okay. So, but on a clear day when the sky is very clear and there's very little moisture, something that's 50 miles away, like a mountain, uh, looks incredibly close. And you keep walking towards it, and it never gets any closer because it's far away. But you see it as being clear, and so you naturally assume that object is closer to you because there's very little atmospheric interference. So human beings get it wrong when it's a clear day, and get it right when it's a foggy day. You know what I mean?
Oh, that's
Yes.
insane. Okay. Yes, yes, yes.
Yeah, it's interesting. Uh,
You brought up Venus, and I have a question about Venus. Actually, I've wanted to ask, but totally forgot until you mentioned Venus. Like Venus, I believe, like rotates one every 243 Earth days,
in the wrong direction, you're right.
and like, how does that affect? Um, I don't know. I mean, for all intents, it's almost standing still, right? It's an
Right.
incredibly slow spin. Like, how does that? Like, it still has cloud cover. Like, how does the lack
Oh,
of spin affect a planet's? I don't know, like characteristic. Like, why does it have
Well, one thing
like
one thing seems to
yeah?
be true. It doesn't seem to have a magnetic field, and I think it's
Oh,
all Venus's fault, uh, because you need a spinning planet to generate a magnetic field. So
that's
Venus
interesting.
is missing the magnetic field. So it's also missing. You could also say that because it's lacking a magnetic field, it's also lacking the ability to protect itself from the loss of water from its outer atmosphere.
I was
So,
very surprised to learn that we had a mission to Venus in 1959 and 1962. Mariner 1 and Mariner 2.
yeah, yeah. and
But
and it
Mariner,
was it
yeah,
was one of those missions, I believe, that detected that for that that the surface of Venus was ridiculously hot, like 900 degrees Fahrenheit.
it would be Mariner 2 because Mariner 1 blew up after it took off because of a typo in the software.
Right,
so
right.
is this a new setup for a pickup line? Like you are you Venus because the surface of you is ridiculously hot.
That's funny.
And also because uh, and this I'm a little bit fuzzier about, because Venus doesn't really rotate, uh, it also doesn't experience plate tectonics. Uh, and because it doesn't experience plate tectonics and because it doesn't have any water, the carbon dioxide uh, in its atmosphere never got a chance to be sequestered below the surface by the action of water and carbon dioxide producing carbolic acid and eventually calcium carbonate. Uh, uh, so it uh, limestone. So essentially, Venus is lacking limestone, which would sequester the carbon. If you
Uh,
took all the carbon dioxide in the Earth rocks and put them in the atmosphere, we'd have the atmosphere just like Venus.
But
oh,
isn't the
that's
stuff
fascinating.
the for?
At least it was said to me by my advisor at the time. I don't know if that's still true, but it was said to me.
So I have a quick question.
Yeah.
I just went down the rabbit hole of angular resolution and eyes detecting the pixels. So this
No,
is
a single eye has a different angular resolution than the stereoscopic. Okay, so an individual eye can only resolve certain angular resolution, but I'm talking about distance resolution via stereoscopic vision. That's so if you went down the wrong rabbit hole with pixels.
oh, okay. Oh, so I guess that cancels my question then.
Yeah.
What was
Got
your
you.
question?
So the question is, what is the distance that we as a species stereoscopically can detect? What can we reliably detect with our binocular vision?
Stereoscopically, that means two eyes. Is that
Yeah, yeah,
basically like saying okay?
that's right. Right. So
But
I
we
don't.
do
I
use a
I
combination
gotta
of
go.
binocular vision and like the perceived size of objects and the known size of objects and other things like
Right.
that.
Like I have a friend who has two eyes, but they don't work together to produce binocular vision. So what she does is she drives by judging the size of the cars ahead of her, and she doesn't even know that she doesn't have binocular vision, except she's been tested and she knows it doesn't. But she doesn't experience her lack of binocular vision as not being able to detect distances because she knows the size of objects. You know. So she's compensated for her life. But Dash, are you looking it up? Yeah, he is.
Yes, give me a second. Give me.
Okay.
The perception of an
Well,
oncoming, the speed of an oncoming object would be reduced.
say it again.
Um, if her perception of the speed of an oncoming object would be uh, diminished or something.
I would assume that she's not very good at it, uh, and so when I'm driving in a car with her, I don't like it. So,
Are you
but
saying we either use stereoscopic or binocular, or like, is it a mix of both?
binocular and stereoscopic is the same thing.
Oh,
I mean, you use them differently in different sentences, but yes, it's the same thing.
okay, got it.
Because the way like human eyes are, like we see in 180 degrees, and like animals like horses, where the eyes are more on the sides, or they see them what, like 230 degrees, something
Well,
like
yeah. So animals that are vegetarians don't have binocular vision because they don't need to be able to see how to pounce upon their prey. They need to be able to see uh, who is going to pounce upon them. So they need to see more of the environment at any given time than we do. We just need to be able to see who we're going to kill next, and so we need eyes in front of our head, right? But horses don't, and camels don't. They're vegetarians, and so they just need to protect themselves. So they have wider vision, uh, but no stereoscopic, no binocular vision.
Um, I just want to add that it seems like they just have a ton of like low flying satellites or something going on here. I Yeah, I don't know. It's super weird.
Possibly. So
There
No,
I
are
was
just
the
well,
so
I
question.
many.
wouldn't. Satellites can't low fly.
Can
You
they
know that,
not?
Carla.
Okay, okay. Well, then I
Of
don't
course they
know.
can,
Then I don't
because they
know.
move. They
And the
they move at
goose in the
seventeen
bush is
thousand.
freaking me out.
They move at.
I don't know what they do.
Uh,
Is it
well,
planes?
there have got to be planes because if they're in the
I guess
atmosphere,
they're
they
low
have to be
flying,
planes.
yeah.
Yeah, because if you have
Planes
satellites,
fly.
and there was once on Star Trek, not Star Trek, Sea Hunt, starring Lloyd Bridges, which is I'm 78 years old, so I watched the program on TV called Sea Hunt, and he's the father of Bo Bridges and the other Bridges. But anyway, Lloyd Bridges had a show Sea Hunt, and he had on his program an underwater satellite that went around the Earth every 90 minutes. And as a 10-year-old
Underwater.
child, knew that was so wrong, eh, so wrong. Friction, friction, my dear. So nothing can travel around the Earth in 90 minutes in the atmosphere because it would burn up from friction. Hence, reentry and all that stuff. You know,
Yeah, so that just made me that what you just said, Carla, about seeing satellites. So I went to West Virginia about 3 or 4 months ago to visit my parents, and me and my dad was outside playing with the telescope, and we had actually saw like a string of lights in the sky. It was like a string of. He thought it was birds. I looked.
It was Elon Musk's Starlink satellites.
Yeah, it was one of those things. They was
Yeah,
launching it. So
yeah. It's not the launch. It's after the launch during the deployment.
okay.
Oh, that's interesting. So they have to move into place, right?
Right. So they deploy them and then they come out as a string, which reflects the light. And then after they've come out as a string, then they move around the sky to where their appointed positions.
Got you, man. That was amazing. That sight.
Wow.
What?
I would love to have seen that. That would scare me too.
Yeah, that sounds really super
Yeah,
interesting.
No, no. I mean, think about it. Elon Musk is playing with the whole planet Earth. I mean, the guy is, the richest man on Earth, and he decides to to mess with the sky above your head. Okay, and that's really cheeky of him. You know, and I don't know how many he's got up so far. Maybe 8,000 of them. Not sure. 4 or 8,000.
oh, what's he doing with the sky?
He's filling the sky with satellites,
Too much.
and those satellites will be used to make him money, so he can build more starships, so he can get us all to Mars.
For Starship Enterprise.
Uh,
Yeah.
Starship Enterprise, right? Right. Uh, and meanwhile, make him a lot richer, so he doesn't have to, obey the bounds of propriety. He's his own little nation unto himself.
One interesting thing is that he's always at odds with uh, what's his name, Jeff Bezos.
Uh huh.
Yeah.
Uh, but now Bezos is going to compete with Starlink, and SpaceX is going to launch the satellites for Bezos.
Uh, I read that. I read that, and I find that to be funny. I don't know. I need to find the humor in there because I know there's a lot of humor there. I just don't know why he's doing such a thing, But on the other hand, I know that if he refused to do such a thing, then he would be called maybe petty. There's so much I could, uh, somebody needs to do a full hour on that because there's so much material there,
Oh,
you know.
there
It's
are
Yeah,
hours and hours and hours on YouTube.
right.
it's also kind of different. The constellation that Bezos is working on, Project Scripper, is through Amazon, not Blue Origin. So I guess that kind of maybe provides the degree of separation why they can go to SpaceX instead of Blue Origin.
No, I know they can't use Blue Origin. I know that, but uh, but uh, but I don't know. See, I find it personally annoying that I think we only need. I think what we need to do is nationalize what what uh, Musk is doing, so that we don't do more than one. I don't think our nation needs to do more than one. I know that every nation on earth can't be reasoned with and say, listen, we of the United States have your back. You can use our satellites. In fact, Russia's going, not only do we intend not to use your satellites, but we're going to figure a way to shoot them down, which of course is scarier than anything else. China's
Sibling
doing,
rivalry.
China's doing its own thing. So the three superpowers should put up three constellations. God bless them. We should stop at three, but we shouldn't add a fourth. You know, and so I think Bezos needs to be stopped personally. Uh,
Well,
and
isn't
Elon Musk
companies?
is capable of doing that if he chose to.
But
Well,
the
competition
reason
is good for for moving the technology forward. I
Say again.
think competition is good to move the technology forward.
Still don't understand. I hear what you said though.
I,
I mean,
What,
Competition
what?
is going to
see,
move the
the thing is,
technology forward.
we don't want to clutter low Earth orbit, and we are doing so. And I don't know at exactly what point it becomes tragic that we're doing this. Uh, it's certainly unnecessary for other people to play the same game, but it's even worse if, in fact, it gets so that you start to get what's the word of that effect? What do they call that? I lose the word.
Law
It's
of
a
diminishing returns.
it's
no, no,
okay.
no.
Let's.
It's named after a guy. It's his name. I forget for a second, but
Is it
it's
game theory?
I think we can just
no.
use
But
the
I was gonna
satellites
say
to block out
junkie.
the sunlight that makes us hot, right? So that would save climate. This is the savior of climate change. Is
well,
we
but
just
actually,
No, it
Carla,
would
that's
yeah.
focus
that.
the sunlight and
So
burn up
Carla,
everything.
that's
Really
a very good idea. Okay, and there is one of the people on Clubhouse. Okay,
I was being sarcastic,
a
but okay.
person. No, no, no. But in fact, there's a guy on Clubhouse. I forget his. I think his first name is Lee. Okay, and Lee is what's the word for somebody who's self-taught, like yourself, Carla?
Autodidact.
What is that's right. He's an autodidact, uh, and and uh, and he also is self-taught in the realm of mathematics and physics, and he has enough uh, physics and math to offer what is a reasonable case, but I haven't seen his math to suggest that if we put certain kind of satellites at the L2 point, L1 point, uh, we could block out the sunlight from the sun sufficiently to change climate. And he's been on Clubhouse and in fact in Small Steps and Giant Leaps. And he's almost a quack. The problem is
Mm,
that he's not. He's not. He just hasn't published. Until he publishes and gets accepted into a journal, he's not he's not anyone but just somebody. But as
sure.
soon as he does get his stuff published, and I have offered to help him with his math, and I haven't seen him. He may have gone away, whatever. I don't know where he's gone to, uh, whether he's ill or something else, because he was making a lot of noise for about a year, and he was on all the time. And I liked his idea. I really did. I saw nothing wrong with it. And he brought up things that I didn't think of that were in fact important to discuss, such as, and here's the key word here, the diffraction effect. If you put up a satellite at 1 million miles from the Earth, you don't get a shadow. You do
Yep.
not get a shadow. You get a diffraction ring, and it interferes and
Phew.
with itself, and all of a sudden you've got not a shadow, but in fact a nice bright rainbow in the sky. And it may not at all do what you're expecting it to do. He was dealing with the mathematics of that.
Yeah.
So
Eli
Yeah.
Robot
That's.
I really respected that.
Oh, yeah.
But
Math
I didn't
is
see it.
great.
is his name Eli Rabani?
Yes,
Oh no, he
that's his name.
suggested that.
That's his
Oh
name.
no. I liked
What's
him
happened to
kind
him?
of sometimes. I
I did too
sometimes
because
like him.
he
Not
always
very
made
much
sense.
time though.
sometimes.
Only
I
sometimes.
loved him,
I
but
don't
I
know. He's
only
hanging around.
wanted him, but I wanted him to show his work. That's
Well,
all I asked him.
we have to think
Show his
about
work.
the repercussions. Okay, the planet needs. Okay, how do
The planet
how do
needs
we?
that. Absolutely.
How, no
And
no
he
no
said
no
he was close.
no no. How do we know that the planet doesn't have a certain quota that it has to meet as far as sunlight goes in in effort to keep this thing going? You know what I'm
Well,
saying? What if
see,
there's
but
a
Carl,
certain amount
you're
of solar
starting to go down.
energy?
There is
This is
a
not a
theory
rabbit
called
hole.
no, but this is a theory called the Gaia theory. GAIA.
Sure.
IA.
Yeah, people keep talking to me about that. I don't know.
And Gaia is in fact a worthy conversation, but there's no proof. It's just a worthy conversation, and so that's on that realm of that.
Yeah,
You know what I
well,
mean?
I for a fact, I know we need the energy from the sun. I mean, that's literally how this whole shit's
No,
going,
but the
right?
question is that
Like, come
what
on.
does the Earth see? The Earth is supposedly, according to Gaia, sort of self-healing. It's sort of like in conversation with the cosmos, and it's as if it's a living organism and knows how to deal with sunlight and all that
Yeah,
stuff. And it's
it's
yeah,
definitely one. I don't think it is necessarily a knows how to deal with it situation, but I think
yeah,
that there are natural consequences. Oh God, I love that, natural
yes,
consequences that arise as things change to supplement. So you know, everything that happens has its opposite, and then you know, and then there's like basically just a fundamental change in a given area. Ah, oh, a thing I was
uh,
thinking about.
what?
Okay, this is super cool. So I don't know if anyone ever thinks about this, or maybe I just can't find it online. I don't know what it is. So 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 we have the way that storms move um, in the Pacific, right? And it
Yeah,
goes clockwise, right?
right.
And then we have, the lower Pacific, and then it goes counterclockwise, right?
Right.
Okay, cool, cool. So, but think of it as if you are on so from top to bottom. So you have the Arctic up here, and you have the Antarctic below. So try and imagine yourself on a certain part of the Pacific. Let's say it's northwest, right? California, that's where I am. Um, so say there's a storm here, but let's say that you're taking a stick
Uh,
and you could do the same thing. Like basically you stir water and it
uh.
stirs a certain way, right?
Well,
But
you stir
at
it any way you want. Right.
right. So if you stuck a stick
Uh,
through the earth from that place, the Pacific Northwest,
mm,
all the way down to that ocean,
on the other side.
those that circular motion would be opposite.
Right. Exactly.
Yeah.
This
So
stick. Yeah.
how
Yeah.
well, I'm definitely saying that that is happening,
That's true.
and and but I do want to know from your perspective, because I think there's outward influences like Jupiter. They say is
And
somehow has something to do with our weather
no,
patterns.
no, they don't.
Um.
No, they don't. No, they don't.
Oh, okay. That I
I
was
mean, whoever
I
they
read a
are,
whole
whoever they are,
thing
don't
about
say
it.
that.
It's a
I
flat
Unless
mean,
they,
earthers.
yeah. I mean, no, I read a whole article about it.
I'm sure
I'll
you can
I'll
read
put it
many,
in the
but
chat,
it's
but
still not true.
okay. Well, in any case, so how do you describe that effect?
What effect? The Coriolis effect in different hemispheres being
Right. So,
clockwise and counterclockwise? I think I just did. I just think I just said that.
uh-huh.
That's the explanation. Coriolis effect is clockwise in one hemisphere and counterclockwise in the other hemisphere. That's it.
I just mean, have we accounted for the fact that those 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 events are taking place simultaneously as far
Yes,
as
yes. In fact, there's no other way to. It can't be otherwise. If it was otherwise, then there'd be a lot of physicists who'd have to go home to their mothers,
no, I know,
because they're no longer employed. No,
sorry, I mean
it's
as far as I
It's no
no,
longer
no, no, I'm sorry. I don't think you're understanding me correctly.
I know. I'm sure I'm not.
Okay, so what I'm meaning is that when you have low pressure in a certain part of the Pacific Ocean, Northwest,
Uh,
you would have high pressure on the alternate
no,
side.
no, no.
Okay,
High
so
pressure, low
that is
pressure is no, no. Clockwise, counterclockwise, yes. Okay, that sort of thing. But it doesn't mean that if for every cyclone in the southern hemisphere, there's an equivalent hurricane in the northern hemisphere. No, that's
it
not
would
true.
not be equivalent.
Well,
However,
sorry,
there
it's
would
not.
be
They form independently of one another. They don't correlate with one another. Yes, I would say
okay,
that.
I think there are distinctions that we can actually look at as far as the high pressure, low pressure grid, and actually orienting it an alternative way, because I think we're missing part of the picture. Because for me, that is what I see as far as where the high and low pressure are consistent in given areas, and fluctuate.
Well,
Um,
you're seeing a pattern, okay? You're seeing a
yeah, I'm seeing a
pattern.
pattern.
But
Yeah.
You're seeing a, and
but that's a specific
human
weather
beings,
patterns.
human beings are very good at pattern recognition, but that's because we need to do that to be sure that we don't get eaten by tigers. So we are really good at that. But that doesn't mean we're right, okay? Because we also get it wrong just as often as we get it right. It doesn't, there's no consequence
Well,
to
it's
getting it
worth
wrong.
looking into.
Well, of course, it's worth looking into because if you see a tiger, it's worthwhile running the other way. In fact, but it doesn't mean you're right. It
Yeah,
just
I just
means
okay,
it keeps you safe.
sure, but
So
I'm never mind.
no. So patterns is what we do. But also, I have to explain something. Not explain, but say something to you. In this new world that we live in, the we have replaced our pattern recognition brains with the brains of artificial intelligence, and we can ask the AI robots to recognize patterns that we otherwise do not see, and it can in fact tell us things that we didn't know before. So if you are serious about this particular pattern that you're
100.
recognizing, you might incorporate or in fact train a AI robot to examine the weather on our planet over the last say 20 years, train it on that, okay, and then ask it whether there's any correlation between the weather in the north and the weather in the south. And it could tell you the answer. In the absence of an AI or robot answering that question, which I believe, if you ask it that question quietly enough, it might say, well, there's a small correlation. But to my mind, and I'm not an AI robot, I have to tell you, I don't think so.
No, that's fine. I'm just asking if you know anything about that, but thank
No,
you.
no, no, no. And the reason being, of course, that I can't see any reason why there would be a correlation.
Well, we
So that's why I'm saying
do look at the weather pattern as one, and that's the only way that we're able
no,
to
no,
judge,
n-
to
n-
forecast what the weather
no,
is.
no, no,
Okay.
no. No, we don't look at the weather pattern as one. We look at the weather pattern as being a series of cells of smaller and smaller nature as we have more and more data. And we use that data, the weather pattern, each of those cells independently. And we see how each of those cells influence the neighboring cells. And if I could ever say anything to be the exact opposite of true, that's the exact opposite of true. We look at the weather not as one, but as a series of small things that ultimately come together to produce the whole. But it's not the whole that produces the parts, it's the parts that produce the whole.
Okay, so then why do we discount ecosystems? Like, why? I mean, it's like it just becomes this major deficiency in in actually understanding the concept. Because if you say,
What
you
concept?
know, that
What concept?
we're looking at each piece and seeing how each piece goes, we're not seeing it as a whole.
No, no,
That
because we piece it
each
together.
piece is part of the whole. So
And what we do
I
is
it's
there's an entire
glaringly
science,
it's annoying to me.
is an entire science of climate stuff. It's done inside of
And they
computers
can't figure
in
it
which
out.
who said they can't figure
They
it out?
can't figure it out. They don't know why.
What can't they?
They don't know why
What don't they
the
know?
they
What
don't
don't
know
they know?
why the El
No,
Nino
why?
and the La
Why what?
Nina happen when they do. They
Are
don't
you
know
kidding
why.
me? Are you kidding me?
No, they actually don't know why.
Okay, I don't. As I said earlier, I don't know much about
They
that.
don't know
Okay,
why.
but I would be surprised. I would be extremely surprised. I would be willing to bet money on the basis of a non-information that I have. Okay, that
Go ahead.
we know why. We know why El Nino and El Nina. I bet you if I
Yeah,
looked it up
winds
in
changing.
Wikipedia,
So why did the winds change? What
but they know
would
that too. They know all that stuff. It's
no,
not like they
no?
don't know
Because
that.
you know what?
You
No, 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 no. because I
They can
literally put
predict
this in the
climate. They
chat.
can
No, no, no,
predict
no, no, no.
stuff like
I
that.
just put it in the chat earlier. They literally
Yes.
said something that I made a diagram about 3 months ago now, and I told you orographic rainfall with a mountain is a really big fucking deal, and it has to do with weather and climate.
It
And
does. It
that's
has
super
something,
cool.
sure.
But guess what?
What?
They said that is what is causing the El Nino. Okay, so the
Maybe
diagram
it
that I
is.
made
Maybe it is.
3 months ago says the mountains, the mountains, the mountains
Okay.
have something to do with it. So you know, like as much as we
I,
want to
I,
say, oh
I'm looking at your thing that you
yeah,
posted. Okay, I am looking, and
we
let me read it. The study
it's just
suggests that along this corridor, the presence of mountains can be expected to amplify El Nino related increase in precipitation by 2 to 6% times, but that increase is most evident in the western side of mountains because of what is known as the orographic effect. Okay, so
Which mountains are hundreds of thousands of
th-
mountains on the
now
planet?
I'm looking at the publication, and the publication is called phys.org, and I I think that is a worthy publication. I do believe, uh, and so uh, and so you're if you are so Carla, I mean, I am interested in the fact that that I seem to be inappropriately wrong about how mountains affect climate. If it this, I take this statement here to be close to fact. Okay, and as a result, I would have to say, on the basis of reading just that paragraph, by the way, but nevertheless, I think it's reasonable uh, to say that what you said is correct as far as that's concerned. Uh, and so, if I in fact said earlier that mountains have nothing to do with climate, then I need to retract that statement. Okay. Uh, so, but I don't know to the extent to which I have to retract that statement because I didn't read this article. But that paragraph is certainly interesting.
sure. Well, I guess the point for me is they're still pointing to reasons why this happens, so that they haven't really come to a conclusion on on well, definitely one thing. So they're still, I mean, they're just not 100% getting the picture, and
Well,
that's what I'm.
you said that El Nino wasn't explained. This article doesn't say that. This article says that mountains affect El Nino induced winter precipitation. That is what this article is the
Yes.
title of the article, and I concur based upon the little piece of that I read.
Right.
Okay, and I'm seeing so I agree. I agree, but and to the extent that that affects climate, I also agree. But I also would point out that the precipitation that we're talking about is local to the mountains, okay? And climate is, in fact, is not local to a particular area so much as
Right.
it's a broad thing.
It's a great point.
So
Yeah.
I'm not willing to completely retract my statement that that
Absolutely.
we so
Absolutely.
don't.
I think you're
But I do
absolutely
agree with that
right.
said.
And
Yes,
seeing those two things as conflicting.
right.
Absolutely.
Well, I don't see
And
it's conflicting, but I do see it's what you said.
needs more information. It needs more information.
You know, the thing that the thing that 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 the way that people argue when they are not, in fact, the scientists of record in a particular field. The people, because you know everybody gets qualified in a particular field, and they get PhDs, and they get tenure and professorships and all that sort of stuff, and that gives them credentials, and 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 those people have the right to say things, you know, that are true, and the rest of us are just, you know, opining our opinions. The what was I about to say? When people who are, if you will, among the unwashed and unqualified speak, they often begin with, This is a phenomenon. Scientists can't explain it. Here's an explanation. That is the pattern of most non-scientific explanations. And whenever I hear that sort of pattern, I I start to laugh. Okay, so I do find that. So I do think that that in El Nino is explained, and that there are still questions to be asked and answered as well. But I think the it is would be it would be laughable to my mind at this point to say it's not explained. There's too much science been going on for too long for me to buy as a statement that we don't understand what it is. We do not understand certain phenomenon that may in fact be corollaries to that. But I think the actual phenomenon is known. And if you look it up, I'm sure you'd find it.
Well, there's comprehensive understanding, and then there's just a loose, like, I think it's this and this. And what I see
No,
is, I
no,
think it's
no, no.
this
There
and
are people.
this.
There are people with degrees who say not I
Guess
think, but
what?
I can prove.
Guess what? Like, literally, like, you say, okay, we look at it in pieces, and then we discount ecosystems as being not important and what goes on in ecosystems
Well, you
as
know,
not
I
being important.
okay. So your ongoing thesis, and I really
Train.
think, and I think I know it, Train, and I'll hear it again, I'm sure, in 2 seconds, is uh, the your ongoing thesis, I think, is worthy. Okay, I think that the your ongoing thesis that ecosystems have an effect on things that we have not taken into account. Okay, I think that's a worthy pursuit. Okay, I do think that there has probably not been enough discussion. Why? Because it's cross disciplines, uh, and because with the discipline of climate and the discipline of biology, uh, that that there is probably an enormous amount of stuff we don't know that you are trying to investigate. I just don't know that you're the best investigator, but you are a good person to ask the question. You're a
I'm
good
not the
person to
best.
ask the question.
How dare you? Shut up,
you,
Laird. I'm not
you're
the.
an
Do you
autodidact.
even? Oh my God. The amount of fucking information I have consumed and
I
don't
know.
remember, but
I
understand the system like
no.
extremely well,
Carl,
extraordinarily well.
Carl,
Listen, no,
autodidacts.
no, no. No, what you need to do is sponsor my fucking education. That's what you need to do. Because if anyone, no, don't you fucking laugh. Don't you fucking laugh. Excuse me. If anyone sponsored my education, deal's going to be done. We're going to understand what the fuck is going on. And I
I
mean, I mean
I
fully
understand.
understand
I get it.
what
I
is
get it.
possible to understand.
I get
So,
it. No, I really,
but no, I'm seriously saying I need someone to
no,
sponsor my
my
education
education was,
because
my
guess what?
education was
Guess
sponsored by NASA. My education was sponsored by NASA.
great.
I didn't pay a penny. Uh, uh, if you try to do the same
Nice.
thing with your crossed things, you will probably not find a sponsor for your
Well,
education,
thanks.
and and as I said before, and I'll say it again, is your questions deserve to be
Okay.
answered,
Well,
but
this
you don't.
I literally am
But
looking for someone to sponsor my education because I'm working 14 hours a fucking day helping kids learn to speak, okay? Um and the only thing that I actually want to do um is actually help the world not die within itself, okay?
oh,
I
and you're
want us
absolutely.
to not, implode, which is what we're doing, which is we're imploding.
Well, let me
Um
ask you a question. Let me ask you a question.
Bless you, Carla.
Serious question. I know that I know I deserve what you said and all the curse words you used. Okay, uh, 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 I know that. I give you that perfectly. But I'm curious as to what it actually would take, in reality, for you to actually gain the education that you covet. And I'm not being facetious here, okay, or sarcastic. I'm saying is, you have you work, you don't have the money, you don't have the time. What would it take if suddenly out of the clear blue sky would come the sponsor of your dreams? What would it take for you to get there, given you had the money? How much money would it take for you to get there? And time. How much time and money would it take for you to get there? And if you said something like $250,000, I wouldn't think you were anywhere far off.
I mean,
And if you said $500,000, I wouldn't think you were far off
I
either.
don't. I no. I don't even think those things actually. Um, uh, because what I specifically want to study is bioprecipitation. That's what it's always been for me. And everyone contests that, that doesn't exist because they don't know anything about it. And that's
Hmm?
fine. Um, but because it's not like the super most studied thing, what I really need is, well, what I really would require would be mentors, within the field, and having their input, and being educated by people who are actually working on these types of research.
Carla,
Um,
I'll offer you something, okay? I happen to have been fired, and I've told you this before in this room, by the world's most prominent climatologist, okay? Uh, and he uh, and I have corresponded recently in the last year. And I said, thank you for firing me. And he said, I was always upset that I fired you. And this is long before he was, and this is long before he was a climatologist. He was just head of the NASA Institute for Space Studies at Columbia, in New York City, and that's when we were working together. And you can look up his name and my name together. My name is Laird Whitehill. His name is James Hansen. Okay, uh, James Hansen is uh, is famous in the world of climatology. Look him up. Okay,
I
you
read
write
some of his articles.
right. You write a letter. Okay, using your best stuff. Okay, best stuff. No, you know, everything you can say about what you want to say, and and send it to me. I will, okay, look at it, edit it to take out all the stuff that is not science, and just and leave in the hypotheses.
He's
Now listen to me. Hypotheses are fine. Hypotheses are fine. But when you back it up with things that are not science, then you are backing it up with other hypotheses, right? So let's go with hypothesis and everything you know in science that backs up your hypothesis, okay? And then, so now we have what amounts to what's called a paper, okay? So I'm asking you to write a paper, okay? And in that, and I would forward that paper to Jim Hansen.
Wow,
Okay,
that's such a
sure.
right?
I mean, at this
But
point,
I'm
it's
asking you to
really
write a
super
paper.
short.
What? What? No, no. But
Oh,
you have studied a lot. Put everything you know that is
no, I've
science
already reduced it
in,
down.
and use it, and put it down. Put in your hypothesis and say these are the things that support my hypothesis, and these are scientific truths. Okay, but you can't use anything that isn't science in the body of the work. Okay, you can only draw conclusions from science in the hypothesis.
Well, you would be then basing that on what you know. So, I
No, no, no.
mean, as far as
I won't risk sending
having
something to. I
references,
wouldn't send it. References would be very
yeah, I'll
useful. You
just,
know what I mean? They're
I mean,
called
on my
references,
website, there's like
right?
5 million references. There's like 50 of
Not
them.
useful. I'm asking you to write a paper.
I
Okay,
know,
a
I'm just
paper with
saying, I don't have any
footnotes,
problem with
footnotes,
using
and
references.
right. The references should be in
Have you
scientific journals, not
have you ever
articles in
Yeah, I
newspapers.
know.
Uh,
Yeah, I
and,
understand what
and
you're saying.
as such, and as such,
I
it
only
becomes.
posted
Listen,
the article in this.
what happens, there have been scientists who have come out of nowhere to become famous simply because they wrote an article that, in fact, became important. One of those people was like Albert Einstein, right? Uh, a little bit of reference here, a little bit of reference there. People buy into it. People buy into articles that are well argued and well referenced. Uh, and even though you don't have the education for it, you are perfectly allowed to submit to any journal on earth. And while you may not have the credentials, you definitely can claim that you didn't read my article because if you had, you would have published it, kind of thing.
But
And so,
Carla,
so
you said that some people say that bio precipitation doesn't exist, but you
Yeah,
also
the people that don't know. Yeah.
but there but you also said that there are experts in the field.
It,
So why don't you bring
as
together these experts and maybe interview them on YouTube or something, and then you can further
I mean,
your influence like that. I mean, you're already influencing all of us in this room because none of us probably ever thought of uh,
right. Well,
bio.
it almost, the bioprecipitation aspect almost doesn't matter. The only thing that matters is isostatic pressure, and that's why mountains are important. So as far as them saying, hey, mountains are responsible for El Nino, isostatic pressure is at play. And those are the specific things that I want to talk about. Um, Apart from that, the the other side of that, the dimension of that, is the growth of ecosystems. So the growth of ecosystems would be capturing gases. The gas would make the area lighter, then put pressure in a different position, and because of that change in pressure and gravity, that's why you get heat and no rain on one side of the mountain, because it's being pressed so deeply into the earth, and then on the other side it's lifted. But that's how it goes.
right, and that's not science, to my
I don't
mind,
care. I'm
because you know
just
what?
telling
No,
you
but listen,
that.
listen. But let me
That's,
tell you. Let me tell you something,
I'm
Carla.
not
Let me
giving
tell you
you a
something.
paper.
No, 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 no. But I'm telling you what you can do, and what I could literally help you do. Okay, is I can do the calculations. Okay, you can say what you said, and I can put numbers to that. Okay, so if you don't put numbers to it, you can't make the argument. But you can put numbers to it. The argument you've just made can be digitized. And as such, I urge you to digitize it. And if you can't, I'd be happy to put numbers to your assertions. Okay? Because what you said is true. The only thing that's different is the numbers.
It's probably
Sure.
already been, I would imagine.
I would doubt. I would doubt it.
Can can I can I just ask one thing about the um, isometric pressure differential on one side or the other of the
Isostatic
mountain?
pressure.
Isostatic.
Isostatic, sorry.
Yes.
Is this related or different from the adiabatic effect?
Adiabatic effect is a word completely unrelated.
Right, but it describes the effect that we're looking at, right?
No.
It's
No, she says
wetter
that
on one side of the mountain than
she
on the
says
other.
that she says the atmosphere is heavier on one side than the other.
It is.
And if it is,
There's there's
then
more water,
if it is, then the air pressure would be higher on one side than the other.
but there's more water in the atmosphere on one side of the mountain, and it precipitates, and there's less water on the other side.
That is true. That's true. But what is the difference in the barometric pressure on one side of the mountain versus the other? That's the only question, and that can be digitized in terms of a weight, and you can
Right,
compare that to the weight of the rock that you have in your hand. And I'm
right.
saying and I'm saying
Yeah,
that if I pick up a piece of rock that's 14.7 pounds, that's the entire weight of the atmosphere above her head. And she's saying it makes a difference. And I'm saying is if I pile a sheet of rocks on one side of the mountain, that in fact is 14.7 pounds per square inch, that I've basically doubled the pressure of the atmosphere. And she says that the atmosphere is much heavier than that. And I'm saying, no, it isn't.
gotcha.
We didn't get into that, but sure. So you're already disagreeing with me, which
I am
is
absolutely disagreeing with you.
okay. Okay. So in that in that regard, it doesn't sound like you're the right person to
No,
do any math for me.
you may be right because I disagree with you going in,
Yeah, if you're
but
already
I
biased
can
and
do
you've
the
already
math.
disagreed with me, like what the hell? Like why would you
Well,
even
That,
oh, let
no,
me
arguably,
no,
do the
no.
math and let
But
you
I,
know that you're
That
wrong.
that
but
no,
Like
that
that's
do
the
the
whole
math,
point why you
Carla. Do
apply
the
the math
math.
to
Do the
remove the
math,
bias.
Carla. Do the math.
this
That's what
would
I'm
be
saying.
someone else
Do the
doing the
math.
math.
Why can't you do the math?
Oh, because I'm not a math person. Uh-uh.
It's not math. This is arithmetic. This is arithmetic. It's simple. Pressure is force per square inch. Okay,
Oh,
that's a
square
definition.
inch.
Pressure is force per square inch. That's the definition of pressure. Okay, uh, so uh, the atmosphere has a pressure on the Earth's surface of 14.7 pounds per square inch. So if you take a square inch, you can figure out that there's a force of 14.7 pounds on that square inch. Okay, now you know what the force is of the atmosphere on that piece of rock. Okay, now if I take a piece of rock that weighs 14.7 pounds and I put it on that square inch, I have just doubled the weight of the atmosphere on that. Okay, so I don't have a closed mind, I just have a mathematical mind. All right, and you're not using the math, and you're claiming that you can't do the math, but this is just arithmetic. Okay, and I challenge
Okay,
you to do
maybe I
the
can do the
arithmetic.
math.
Do the
Maybe I
math.
can do the math. I
Do the
already did a
math.
bunch of math and everyone like laughed at it and said that water moving around on the Earth's surface wouldn't change anything. And yet, here we go.
There it goes.
We have a perfect, we have a perfect example of mountains and the changes in pressure and orographic rainfall, and it's like water moving around is not going to change anything. There's just, you know, you can say something's not going to change something so many times, like this tree being cut down is not going to change anything, and this one, and this one, and this one, and
Well,
this one
it
being cut
certainly
down
does,
isn't going to
but
change anything.
that's
And
off
that's
topic,
that's
isn't
what
it?
we have the tendency to do. But I do think that dismissal, that rejection that you
I
feel,
didn't
is
dismiss you.
that saying,
I didn't dismiss what you said. I argued against it, and I offered numbers, and you haven't offered any numbers.
Can
Okay,
I
oh,
I
I
offered
did a
numbers
ton of
that
math
right
of
in front of you.
water.
I've just told
can I
you that the weight of the atmosphere can be replaced by a rock that is weighs 14.7 pounds on a square inch of land. And so all I have to do is build a mountain up so that I've increased the pressure by 14.7 pounds on every square inch of the mountain. And yeah,
can I
that will definitely have an effect.
can I
But
Well,
you're
interject one?
doubling the
what you
atmospheric pressure.
Can I?
actually want to do is lower the pressure on the western slope of the mountain.
Yes, yes, exactly. And can I just interject one thing? Is that yes, the column of air on both sides weighs the same, but the local pressure at the base of the column on one side of the mountain and the other is not equal because the air on the other side of the mountain is warmer. And so the actual pressure on one side or the other is not equal. The mass of the column of air is, but the local pressure at the base is less because that rock moving from one side of the mountain to the other has morphed from granite to pumice because it's shed a butt ton of water on one side from the other,
Right.
and it actually increases in temperature on the other side. So the local air pressure on the other side of the mountain is less.
Let me ask you, Jean Frederic. So I'm standing at the same height on either side of the mountain. Okay. And I notice that, and I carry with me a barometer,
Right,
and a barometer measures air pressure,
right,
and air pressure does change from time to time with the weather, with the time of
exactly.
day, all that stuff. Okay, are you saying that one side of the mountain always has a lower air pressure than the other?
The movement of the air across the mountain means that it's going to shed moisture and it's
Of
going to
course,
change temperature.
temperature, of
So
course,
the temperature of the air on one side or the other is different. And
absolutely.
so, yes, locally, your air is
But
going
I'm
to be
asking about the air
light.
pressure.
The
Air
air
pressure.
pressure, the air pressure will be lighter, and even you don't have to cross the mountain because the air crossing you will change air pressures. That's why we get wind, right? So
Right,
we
but I
have
am asking an actual question.
of yeah.
Is it a systematic effect that the air on one side of the lee side of a mountain is in fact uh, heavier than heavier, meaning higher pressure than the leading edge of the mountain? Is it always true basically depending upon the prevailing winds.
Based on the prevailing winds, yes, that's why you have a wet side and a dry side.
But I'm saying is so you're saying that it's always true that one side of the mountain is lower pressure than the other,
If
and
there's a wind.
systematically,
If there's a wind.
if there's a wind, right,
If there's a wind.
right,
It's the same effect we get with wings and so on. That's why when that's why I'm expecting the snow melt to the snow to melt pretty quickly in Switzerland, because we're going to get a bunch of moist air coming from North Africa, sweeping up, dumping a bunch of rain on one side, and then warming up more on the other. And so
right,
you're going to have, and that's why we have a desert on on my side of the Rockies, on your side of the Rockies also, and not on the other.
right. No, absolutely. But
Yeah,
so speak to Carla's hypothesis, okay? Do you understand her hypothesis?
yeah. It's the concept that somehow there's a property that means that, and I didn't quite grasp the whole thing because I was trying to read into bioprecipitation, which is pretty well annotated on Wikipedia, and there's
Right,
several references at the bottom of the article.
right.
But
What is her
but
thesis? Do you know what her thesis is?
the thesis would be that there is a biological effect that acts on fundamental physical properties. But the question is, do the observed effects even need that? As far as I can tell, the adiabatic effect is enough
Right.
to explain the whole
And by the way,
thing.
Jake, when I said that the adiabatic effect is not important here, I maybe misspoke because, in fact, I think it is important in the sense of that explains entirely why there is, in fact, higher rainfall as you go up, and why clouds form and all that stuff, and why stuff falls on the lee side of a mountain. All of that is due to the adiabatic effect. So I misspoke when I said it wasn't important. I just think it wasn't important in terms of the weight business, but it is
Yeah.
important in
The,
terms
the,
of
the
weather,
weight is the weight is the effect of gravity on the whole column of air, but that column of air is not uniform.
right? So again, let me ask you this: do you understand what I was saying, and do you agree with anything I've said
About
about what Carl says?
uh, that she should write a paper.
Yes,
Yes. No, absolutely. Absolutely. Carla should condense her whole hypothesis into a paper,
right.
and
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 send it to
it,
you,
that
not
and
me.
that process.
Send it to you. Send it
Well,
to
I
you.
don't
Oh,
know
I'm not
who
sending
was
it.
the
I'm
guy.
not sending
No,
it to
no,
that
but who
asshole.
was the
He's
who was
come at
the
me like
who was
being
the
a
guy who was
terrible
the
that
guy
I
you
had not
mentioned?
You're
understood.
funny, Laird. Yeah.
Jim
Who
Hansen,
was
but I won't send it to
Jim
him
Henson? Okay,
unless
but
I,
the
I
thing
won't
is,
I won't send it to him unless it passed my review. So,
Yeah, I'm
sure.
not. I'm
but
not
you
engaging in that
But
type of deal with
you're
you.
the best person to between all of us. You're the best person to actually analyze a scientific paper. But then
no,
I
but you
would suggest that
but
she
you're
send it to the people whose are referenced at the bottom of the article on bioprecipitation.
actually, that's a good idea. Instead of trying to get it published by, in fact, a worthy publication, it's much more likely to be read by someone who, in fact, is in the field. I do know. I used to commune with Carl Sagan and what's his name, and Frank Drake, and they in their classes that I took
What a
would
wonderful name.
from time to time talk about the papers that they received from people, and I was able to see just one of them. I think Sagan showed me one, uh, and they're basically filled. This one paper, what I saw, was filled with calculations and all sorts of stuff that were just meaningless, and basically, famous scientists attract uh, publications or papers by people who, in fact, have something to say. But every now and then, somebody sends them something and somebody reads it, and it becomes like a world changing event. There's a guy named Chandra Sekhar, I forget who what he was. But he wrote a paper. On the basis of that paper, uh, the certain group of scientists sponsored. This was a guy, no education, autodidact, uh, wrote a paper on radiation, and they literally got together a fund to bring him to the United States to give him the education that he needed, uh, because he was just like spectacular in that he was able to say things and know things that nobody else had ever thought of. So it's not like people who are autodidacts can't in fact prove and know things that others don't. It's just that they need to get recognized, and the way to get recognized is via writing a paper. And if you do that, you can begin to find your way into the world of people who will talk to you. You know, the world of science is not closed. It's hard to penetrate if you don't have credentials. But I mean, uh, I have credentials, and I wouldn't be recognized because I don't have sufficient background to be able to write something.
Well, I would ask you, anyone, I made my diagram about orographic rainfall and the mountains and gravity, all that. I did that back in October, and the specific study that points to mountains having to do with El Nino was only published just yesterday. Yesterday.
Okay.
So how would it be that if I didn't understand something here, that I would be able to anticipate that within my hypothesis?
I can't speak, Carla. I can't speak to what you just said because I didn't read what you wrote. I did read what that people wrote. So if you said
No, I
something
made a
and you wrote it
diagram.
down,
No, I made a
no, no,
diagram.
but I need to see it. I don't have it in my hand. You could literally email me. You could
I had
literally
it
email. You
as
could
my
email.
profile picture like months
Hold on,
ago.
let me see.
But this is just showing from when I started it, which was October 12th or something.
Mm, uh, uh, right. Hold on. Sorry, I'm distracted by Clubhouse stuff.
No, that's fine.
Uh,
But
uh,
this
uh,
was the
no,
final outcome as
I'd
far
be happy
as
to.
the
I'd be
Amazon
happy to
River
receive.
Basin.
I'd be happy to receive it. And also,
No,
look.
no, I'm just saying, how would those two things be able to,
But I can't
like,
tell you what. I can't tell you
if
what
I
you
didn't
said.
understand a
I can't
system?
tell you what you said because I don't have it in front of me to read. So no matter how much you
Wait, I made a
testify about what you
diagram.
wrote,
What do you mean?
you could
I
you can
put it
say
in
what
a
you wrote, but
diagram.
good.
I put it in a diagram. It's
You
right there.
put it in a diagram. Thank you very much for having put it in a diagram, but I haven't seen it in my hands. Yeah, I have an email address I can be
Okay,
emailed, and I
but
can look at the
But
diagram.
just as far as like, I mean, anyone else, if anyone else wants to actually answer that, how would I be able to pinpoint um, something so vital in climate without understanding the system?
But since we haven't seen
That,
what you've said, we
I
can't
did. I
agree
put it
what
well,
as
you've
my
said.
but
diagram.
Okay, okay,
okay,
It's right
but
there.
let's say that you understand it. Let's
okay.
say
Let's
that
say
you
it.
understand it,
Thank you for that.
and that you've diagrammed it.
Yes.
So that's called a hunch. And science is when other people understand it. And so you have to send it to somebody else, and they look at it and they go,
Thanks,
ah,
Colin.
yeah, I get it. And it works. And then it's called science. And all science starts with a hunch. Somebody has a hunch and then does the science and then shows it to other people. And those other
Okay, I
people
would
say,
appreciate if you stopped calling
that's
it a
right.
hunch. It's definitely
No, no, but
hypothesis.
it
Like,
is. It
it's
is.
not
A
a
But
hunch.
hypothesis. A
a
hypothesis is
hypothesis
a
is a
hunch. Same
cleaned
I
thing.
up
would not.
hunch.
Yes.
I think it's very
Cleaned
It's
up
a
reduction.
cleaned
hunch.
up
I think it's
hunch.
very reductionary to say that. So I
But
don't
it is.
appreciate it.
But it is. But that's
It's.
it's
I'm
no.
not
But it's
appreciating that. So
but it's a hunch before you've
no,
written it down.
no,
Then it.
no.
What was that Adam Savage said from MythBusters? The difference between science and just doing stuff is writing it down. And
Is
you've
that what
done that. You've
he said that?
Who
That's
didn't?
I
he
love
said
that.
Who said I
it's
didn't
literally the
already?
difference.
Who said I didn't already try an experiment and then come up
Yes,
with rain?
but
Who
did anybody else
knows?
see it?
Sure.
And Adam Savage actually, I think the quote is the difference between science and screwing around is writing it down, but I paraphrased. Um, um, but
you know,
basically,
John Frederick, off
yeah.
topic, but on this topic of Adam Savage, I find his science to be a little. I don't like his science very much. I like his technology a lot,
Yeah.
but I think his science it, suffers from a lack of science.
Well, to his point, he's never actually pretended
He's
to be a
screwing around.
scientist. He's screwing around.
Okay.
He's right. He's not necessarily writing it down so much as he's showing it on TV. But
Right, that's right.
yeah, that's the difference. But he's not pretending really to be a scientist. He's an entertainer.
Right.
So, but the the quote is correct. You
That
know,
is
it's
really
the
good.
difference is writing it down, and then as an added corollary, showing it to other people and them actually nodding their heads up and down, and at
Right.
that point you've achieved science.
You
Well, no,
know,
there's
I once had it explained to me that the difference between creativity and non-creativity is whether or not other people see it. Uh, so you can be as creative as hell, okay? Create the world's most incredible pictures, drawings, or in your case, Jean Frederic, buildings, okay? But if no one ever sees it, you can just go to your grave thinking you're creative, but that doesn't make you creative. You have to have other people see it before it becomes creative. And
Well,
I think that's annoying but true.
it's true. It's true. If I were creating buildings that nobody ever sees, I wouldn't be an architect. I'd be a civil engineer, and I'd be designing bunkers. But
Very good.
you don't see those. But yeah, no, my job is the most in your face act of violence you can possibly do, because I'm making something that's going to be here that you're going to have to stare at long after all of us are dead. And
Yeah.
yeah, you know, I continuously say that architecture is violence, but
Yeah. Nice. Nice. Nice.
it's there whether you like it or not. So yeah, so people have to, you just have to put it out there and people have to see it, otherwise it's the tree
Y-
falling in the woods.
Right. So people, when
Yeah, no
people
one will
call me
ever see
creative,
what they don't want
when
to. So
people call me creative, it's because I have actually gotten a comment on Clubhouse, and I've copied it, I printed it, and I've said show to my wife, look, see how creative I am, uh, and it's I use the testimony of others to prove to my wife that I'm creative. You see, but you do need the testimony of others. Uh,
Testimonial.
if your wife disagrees,
She still doesn't believe you.
well, she's not a scientist, and she doesn't, and she and I share the same 50 years of our lives together, uh, but we don't necessarily agree on very much. That's just what it is. But so you need people who agree with you, in order for you to have created. And listen, just because people agree with you doesn't mean you're right either. Certainly doesn't mean you're right. I mean, I think it was Richard Feynman, but a very very important scientist. The way that science moves forward is at the death of one scientist at a time. In other words, it requires the death of somebody who already will not change their minds before science itself moves a step forward. I like that because I think there's an awful lot of truth in that. So, Carly, what you need is for me to die off so that I no longer stand in your way, preventing your version of science to take hold. You see, it's my fault, and you can just await my demise before what you have to say becomes the reality that we all subscribe to. You know.
can someone summarize Carla's idea in like one sentence so I really understand?
Well,
Or
I can't, but Carla can.
you you can't,
No,
Laird?
I can't. I really can't. I really have. I really don't understand it enough to explain it. No.
It's some effect. I'm calling it the Moxley effect.
Okay.
Um,
But that's my fault, by the way, Jake. That's not hers. I no really. In fact, uh, she and I have communicated via email uh, uh, in the past. And in the past, I have literally written her an email which says, "You're wrong, period, end of sentence. Nothing you said makes sense." I have said those words to her, but she wrote it to me. So the fact that I can't repeat it back is my fault, not hers. Okay?
But
Really.
is it just one thing? Is it just one effect, or is it multiple ideas? Or
The movement of water on Earth's surface allows for carbon sequestration. Trapping of gases allows for lift to take place, and in particular ecosystems, that would give you the orographic effect, and that would start a chain of events that would lead to climate cooling and or climate heating.
and orographic? That's a new word for me.
But
What is that?
it's an important word. It means mountains, and mountains weigh things and cause the shape of the earth to change as well. Glaciers used to reside a mile high on the northern part of the United States. Part of the United States is still rising because the glaciers disappeared. That's an orographic effect.
Okay.
Oh. Thank you. Okay.
But again, this is also the isostatic pressure of the positioning of the land and the gravity and all that. But you guys all know how to take the wind out of somebody's sails.
Yeah.
So,
Pun
uh,
intended.
so that I understand it completely, we're saying that removing part of, I guess, the partial pressure of the atmosphere has enough of an effect, changing the weight of the atmosphere to affect the ground. That the weight of the distribution of different weights of the atmosphere itself will have an effect on the crust.
Uh, well, yes, but also vice versa. So what's happening in an ecosystem is going to affect the atmosphere because plants and trees create the atmosphere. That's like their main job. And they also release cloud condensation nuclei and all that. So um yeah, so
Right. So I don't quite understand. Uh, uh, to be specific, I don't quite understand that hypothesis as a hypothesis. I'm not saying it's right or wrong. I'm just saying I don't understand it. I don't understand what
yeah,
actually
if you fill
she said.
the land with gas, it becomes lighter, and that means that the the pressure is redistributed um, to the mountains. That's all.
Okay, so what you're saying is that when you're removing the carbon dioxide, for example, from the atmosphere and sequestering it in the ground, it's still a gas?
Yeah, they're breathe. What? Yes, they're cycling gases.
Right, but and forgive me, but my understanding is that it's sequestered not necessarily as a gas but as a mineral. Take, for example, the chalk cliffs in Dover. That's a butt ton of carbon dioxide that got turned into basically seashells by mollusks that died and condensed into essentially limestone, limestone and chalk. And so it's not necessarily just a purely chemical reaction. It's a biological one.
You're saying it's no longer carbon dioxide.
It's
It's
no
just,
longer carbon dioxide. It is now what's chalk again?
Limestone.
Well, that's a
So
different part in the cycle.
So I
So
can't remember.
you're talking about a different time frame.
Yeah,
But
yeah.
she's talking about gas. She's actually talking about actual gas in the rock.
And so gaseous diffusion into the rock, and whether that would be a significant enough effect. I think we basically have to start by calculating the relative difference between the weight, the mass of the atmosphere above a certain point on the Earth and the mass of the crust.
I mean, they're kind of inconsequential. I mean, it's literally just aerating the water within the plants.
Oh, maybe. Well, there's such a thing as dissolved carbon dioxide, right? Like
Yeah.
Right?
like
Yeah.
a seltzer water. You have dissolved carbon dioxide, and the bubbles form
Yeah,
when it
there's
heats up.
natural carbonated water.
Yeah. The bubbles form when the pressure is released.
Yeah. Well, when the it comes out of uh the dissolved form, it turns into gas, right?
Yeah. Which happens when you release the pressure and the bubbles can escape. It's the bubbles are pressurized into the water. And then you get the bends.
Cool. So any gases within the system would increase the buoyancy of the land itself.
Well, you're assuming that there's water underneath.
No, no, it's the isostatic pressure in relation to the buoyancy that I'm speaking about.
So is the gas diffusing into the rock of the crust or into the biological, top layer,
I think that's
like
rather
the soil, the
inconsequential.
actual soil? Well, you're ascribing a mechanical effect between the topsoil and the underlying rock, right?
Yeah,
I'm
you can't
imagining
separate
that
them.
the
They're one.
that yeah, they're not exactly one because I can dig through the topsoil until I hit rock, and I can scrape the topsoil away, uh, which happens a lot.
And when you
But
do, you
there's
release
no
carbon.
actual
Every time you
right,
dig,
but there's no
you
actual
release carbon.
mechanical. The topsoil
Gas.
acts as a spring in this case. It's a cushion. It's a springy surface. So your effect is basically
Sure, but
dampened
because
by the springiness of the topsoil.
it can only move as one. So I'm not
But
sure that
the
your
soil is not
point is a
attached to the
point.
rock. I mean, you've brushed dirt off of a rock. The
What?
the the soil, the topsoil is not physically
Oh,
bonded
it's a.
to the rock.
Oh, yes, it is.
How?
It
Glue?
moves as one. Gravity. What else do you want?
Well, gravity pulls it down. It doesn't. But yeah, it's just the. I'm trying to
You can't
envision the
separate
part
them.
where
You can't
the.
separate them. That's like,
Sure, I can.
I mean,
With a
you
shovel.
can if you want to, but that's literally idiocy.
I mean, I could see how the ocean. I just Googled it, and it says the ocean absorbs 30% of the carbon dioxide that's released into the atmosphere. But
Right.
I I don't see how a rock can absorb carbon dioxide. I don't think that happens.
Well, concrete does, but that's a different process.
No,
That has to
the
do with
soil. What are
hydration.
you guys talking about?
The
What?
soil, the
How are
soil
you?
is a
How are you
biological
confused?
process. The soil is the
How are you
remnants of
confused?
biology. The soil isn't geology; it's biology.
How are you confused?
I'm
Part of
I'm not.
living soil, I can see that where you have
Yeah,
microorganisms that might consume the carbon dioxide.
but non-living soil is
The
sand.
part, the whole would have to move as one when in terms of isostatic pressure. It can't move separately. It moves as one. It distributes pressure in that
Okay,
fashion.
if you pick up the blanket off your bed, does the mattress come up with it?
That is not an equal comparison
How?
because we're not lifting the soil.
Well, what is?
We're not
You're saying
lifting the
it's getting
soil
lighter. It's
apart.
it's getting
We're
it's
not
getting
lifting it
lighter, right?
apart. It stays restricted. It's captured.
By
Like I'm
Isn't
not.
isn't
Your
it
questions are really really dumb. You need to like
No,
actually
but that's the
this
problem is that I
this
don't
whole thing you're
understand. I'm trying
saying.
to ask you to explain it to
I
me.
already
How
told you.
are they,
Look
but
up
how are they
isostatic
bonded?
pressure.
How are they bonded? I
What do you
get the
mean how are
pressure
they
part.
bonded? Roots go like all over the place. I don't know. I don't know what answer you're looking for other than trying to be contrarian.
So roots bond
You
them.
don't have a legitimate question
No,
again.
no, no, no. I'm trying to
No, you
understand the
aren't.
mechanism.
You're again
Roots bonded.
disingenuous.
No, you just introduced roots into this question. So you're saying
Oh
roots
my gosh.
bond the soil to the substrate, to the bedrock, basically. Did I misunderstand? I mean, there was a new word, roots.
Uh, Jean Frederic and everybody. Uh,
Yeah.
Carla didn't mention tonight that she has a website. It's called
Okay. Ah,
feedthefungi.com.
I like
And
that.
she has a lot of diagrams there, which you should and I should look at. Okay?
Absolutely.
And anybody else who's listening, you should look at Carla's website, which is called feedthefungi.com.
I'm
and
there.
and what she is talking about is is covered by a lot of diagrams. I'm not I didn't see any text so much as diagrams, uh, and they refers to a lot of the things that she's been talking about tonight. So I think we owe her uh, uh, to before we talk any further, to look at that so that we at least can say that we've seen what she has to say on her website, and then we can talk about it at some other time. But not tonight, because it's now past the time in which I choose to go to sleep. And I could leave you up to all of you, but I think not. I think tonight we need closure, and closure means closing. Uh, so, uh, so thank you, Carla, for being here and being willing to withstand our uh, sort of rude behavior. She left, I think, and that's all very true. So we should all go. So I'm going to close the
Okay.
room, and I thank you all for being here and playing with me as you have. And thank you, especially Jake and Jean Frederic and Old Milad and Dash and Haris. Thank you all for being here, and thank you. Welcome 118, and we shall end as we leave. So I'm going to press the magic button, which when I was a kid, uh, there was a there was a program on television in which uh, there was this character called Froggy, and he would pluck the magic twanger, and then stuff would happen. So I'm going to pluck the magic twanger and see if this make us all disappear.
bong?